Okay. So, the plan is for today is to do a Leetcode question, firstly, followed by study, which will also take most of the time that I'll be spending here today. And then I'll continue with the Odin Project. The reason why I've been doing the Odin Project more recently is because it's part of, I guess, one of my to-do lists before I even continue with the scheduler app. So the chances of me doing scheduler app today might be slim to none, but it's one of the things that I'll be doing for the scheduler app. So it's going to be one of the things, get up to the end of Flexbox section in the Odin project. That will help me be able to do these last two things. So doing the Odin project today will be pretty good. And I'll be doing that last because that'll be the most motivating thing for me, I think. Leetcode right now is just do it now and then don't worry about it later in the day is basically my thinking. And let me just do now a quick monkey type problem. Oh man. Nah. Alright, that's alright. Vim source code. Okay. Alright, it's going to be a hard problem today. Merge case sorted lists. I know I'm probably not going to be able to solve this without seeing the problem. You're given an array K linked lists. Where each list is sorted in ascending order. Return the sorted linked list that is the result of merging all the individual linked lists. You can at best do a O of n times k, right? 1, 2, 3, 3, 4, 5, 6. Okay. So lists, nothing, empty list, still an empty list. Okay, this is the same thing, isn't it? Explanation, the linked lists are 1, 4, 5, 1 through 4. Yeah. Alright. How do I think about this problem? What's the tricky part of the problem? Let's have a look, right? What's tricky about this? So let's say if we have 2 pointers, right? 1, 1, 3. You know, if we think about these as linked lists, then when we pop from a list, you know, pop 1 again, then pop 3. Damn, I gotta sit down for this. Singly linked list, merge sort, heap properties, push and pop. All right, let's have a look. Let's have a look at this. Gotta put my headphones in. Oh, thank you for subscribing. I wish I could see. Someone else subscribed also. Problem is I can't see the events well. Just gotta need to do that. So I'm gonna go to Botrix. Whoops. This is Twitch. It's Botrix. And I gotta make it Mr. Nope, that's not it, Mr. No, I forgot. Forgot what it's called. Never mind. Activity feed. Justin Hooker, Tejas Thorat, Jack Frost, Network by Matt. Thank you for those follows, guys. Oh, Arcad. Wait. Arcad, Journey to Big Tech. Hey man, is the sub alert sound from Steins Gate? Yes it is. Yes it is. Yes, it's the Tuturu sound from Steins Gate.
Hey guys, it's me, Neetcode again, solving another Leetcode problem. This time we're doing merge k sorted linked lists. Before we've done merging two sorted linked lists, which is an easy problem. I think it was Leetcode 21. So if you haven't solved that one yet, I would recommend doing so because we're basically extending that problem. So this problem is actually easier than you might think for a Leetcode hard problem. There's some really basic ideas that we can use to solve.
Ooh. Thank you, Arcad. Thank you for the sub.
Solve it efficiently. So to illustrate that, I have 4 single node linked lists, right? So each of these linked lists only has one node, right? So 5, for example. So basically, how can we merge them in an efficient way? Let me show you like the general idea. So first, we can merge these two, 5 and 7, right? So the first 2 nodes, when we merge them, we know that the 5 is smaller than the 7, so we put the 5 first. So now we have a partial linked list. So now we want to get the next value, which is 3, and we want to merge it into this linked list. Again, the 3 is smaller than the beginning of the linked list, which is the 5 over here, right? So we can just put the 3 at the beginning. And next, we only have one value left, so we want to merge this 8 into our linked list. And so what's the general idea of how to do that? Well, we're going to have to take our 8, right?
Append it to the end.
Look at this 3, right? Well, it's bigger than the 3, so we're not putting it there. Is it bigger than the 5? Yep. Is it bigger than the 7? Yep, so we're going to put it at the end. So notice how we had to iterate through every single node to find where to put 8. That's kind of a problem, but we did find the output. the output is going to be the 3, 5, 7, and 8. So doing it this way is not the most efficient way to do it, because notice for each node or linked list, we're going to be merging it into our current output or our current, result. We're going to be merging it. That's not going to be super efficient. We have k lists, right? And the total number of nodes we have is n. So every time we're merging a list, we're going to potentially have to iterate through every single node we have so far, which could be big O of n. So the overall time complexity is going to be k times n. Now, I bet you already know where I'm going with the solution now, because the picture really makes it obvious. Why would we merge it like this when by doing that, we're really repeating a lot of work? That's really not the most efficient way to do it. If you know the algorithm merge sort, you know that there's a better way to do this. So, and it's a really basic idea, right? Like, why merge it that way when we can merge these two and merge these two, eliminate a bit of that repeated work, right? And then when we have that, like the 5 and the 7, now using this, we're going to merge these two together as well. And assuming you know the algorithm to merge two sorted linked lists, we will get we'll get the same solution, right? But let's analyze what exactly is going on here. When we did this first step, right, over here, when we went from 4 linked lists, right, 1, 2, 3, 4, and then we went to just 2 of them remaining, right, we did have to iterate, we did have to go through every single node. So this was a O of n operation, right? So it's still not cheap, it's O of n. But the question is, how many times do we have to do this? In this case, we only have to do it 2 times, right? So we did the same thing, we took our...
You did this a while back, and you remember the solution, kind of? I think, merge sort I've done in the past, we'll see.
2 linked lists down here and merge
I'm more
them
concerned
into
about the
our
heap
result.
that's involved here.
And again, we had to potentially iterate through every single one of our 4 nodes, so it was an O of n operation. But basically what we're doing is we're taking our lists and dividing them by 2 every time. So how many times can we take the k lists and divide them
N
by
log
2?
n.
Well, it's going to be log k. This is the part
N log
where
k.
we speed up our algorithm. It's log k. The log k is the number of times we're repeating this O of n step. So in this case, with this algorithm, the total time complexity is going to be n log k. And that's a lot better than the brute force, which was n times k, right?
Sure.
So this is a lot better. Okay, so now let's actually get into...
If that's all it is, what's the point of heap properties? Whoops. Single linked lists, merge sort, heap properties, push and pop. Let me have a think about how he plans out this problem. To merge 2 sorted lists. Yeah, I'm lost for it. Oops. Don't know the solution beyond that explanation. I understand the merge sortness of it, but beyond that, let me write that down though. In Obsidian. So So gonna create a new node. Okay, and we're gonna create merge k sorted lists. Gonna call this linked lists, and merge sort and it's also sorted lists. And make note that we use merge sort. Whoops. But beyond that, how do we actually formulate the problem?
So the code. Remember that we have to understand how to merge two sorted linked lists. So I'm just going to put that function here right now. So
merge
we'll
lists.
have list 1 and list 2 as parameters.
Sure, say there's also a merge function with list 1 and list 2. Ooh, I don't have Vim on. Let's just copy the typing. Okay. And it'll have to return an optional. Oops, that is not right. That is not right. That's not right. That's. Oh man. Okay. L1 while L1 and L2 L1.next L1 equals L1.next and L2 equals L2.next only when L1 is less than L2 val L1 next and merged is equal to list node, and we'd have to return merged.next. I might just call it dummy.next. and we're looking to merge the value. So let's say we don't create a new list node here, but instead dummy.next is equal to card.next is equal to L1 might be able to do that outside. Because we're done with that now. Else means, let's just make it less than equal to. Else means that car.next is L2. And L2 is equal to L2.next. Current is equal to current.next. If that's the case, then you got some value until one of them is out, and then the rest would still be finished off by whichever's left over. Right, so if that's none, then it's assumed L2 would just be that value. I think. And then we got to do something with this. So we said we had an OVN operation. I can kind of understand where a heap might come to play. I mean, I think of like a stack of some kind, where you put something on the stack and then you pop it off with the next thing you find and merge that way. And you keep on doing that until there's only one item in the stack left. I think that would be the way then, but I just need to think about it a little better. If you have a stack, you push something on the stack, you push one of the lists onto the stack, and you push a second list on. If there are two lists, you pop two off so that you can merge them. And after you've merged them, you push it back on. If you do that though, that's still the linear movements that we've been seeing. Unless I can do some recursive thing as well. I mean, whatever you can do recursive, you can do in a while loop as well. So maybe I'm just going to see what he does here.
And we'll return the output list. I'm not even going to do this yet because we know this is not the most important part of the algorithm. That's the Leetcode easy portion. We want to do the real part of the problem, which is merging k linked lists. So the first thing I'm going to handle is the annoying edge cases where maybe the list is null or the list is of length 0. In that case, we can just return an empty linked list. And now to get to the actual problem. So we're basically going to be taking pairs of linked lists and merging them each time. And we're going to keep doing this until there's only one linked list remaining, and that's going to be our output. So while the length of lists is greater than 1, we're going to keep reducing it, right? We're going to keep cutting it in half. So as we merge these lists, I'm going to put them in a new list called merged lists. So now we want to iterate through each of these lists. And each time we know we want to do pairs of linked lists, so my incrementer is going to be 2. So list 1 is just going to be at index I. Now list 2 might be out of bounds, right? Because if we have an odd number of lists and we're incrementing by 2 each time, list 2 could be null, so we have to check that. We'll say it's lists of I plus 1, the adjacent list, but we want to make sure. So if
I plus
1 is in bounds, so we'll check I plus 1 is less than the length of the list, then we'll do that. Otherwise, we're going to say it's none. If it's none, that's still okay, right? Because merging one non-null linked list and one null linked list is perfectly fine. We can still do that. I want to take these two lists, merge them together with my helper function, which I haven't even written yet. And I want to take this and append it.
Hold on. Okay, so if I have none, that means if I have none in L2, nothing happens. Then you return dummy.next. Yeah, there's an edge case that I'm missing here. I hate this. There's gonna be an edge case that I'm missing. Do I care right now? Maybe I'll just see the solution. I think I will. Okay, let's go back.
Our merged list variable over here, where we are storing the lists after we merge them. This is the way I like to do it, but I've seen people do it a different way. But now, so we want to update our lists variable because that's where we're actually getting our lists from. So I'm going to update it with merged lists. So merged list is basically like a temporary variable. And of course, we're going to keep doing that until there's only one list left, and then we're going to return that list. So list of 0. So see, that really wasn't too bad. I mean, you might...
lists equals merged list.
kind of struggle with a little bit of the edge cases, that's perfectly fine. But once you get the idea, you see it's really not that bad. Now we've reduced it to an easy problem. We know how to merge two linked lists. I've done it before in a video, but I'll type it out again really quickly. And maybe if you're lucky, your interviewer won't even want you to merge the lists anyway. But let me go ahead and show off and try to speedrun it and hopefully not have a bug and embarrass myself.
Speedrun it. car is dummy while L1 and L2, that's exactly what I did. If
And I'm
L1
speedrunning it, I'm showing
val
off, but I literally solved this problem
is
right before I
less
recorded this
than
video, so it's not
L2
really a
val
show off.
car.next is L1, L1 dot yeah, and then else tail.next is equal to L2, L2 equals L2 dot next, and then tail is equal to tail.next. And then here's the edge cases,
I'm
right?
basically typing basically off of memory, so just get this over with.
Tail.next is equal to L1, and if L2
And
tail.next
slow typer. Once you
is
guys,
equal to L2.
honestly, once you guys practice enough Leetcode, you'll probably be 10 times better than me and wonder. Okay, so let's dummy dot next. Okay.
Okay. Is that not just...
Again, let me prove to myself that I don't have any bugs. And I do. So, okay, so it was pretty small.
append?
Merged lists dot append. We're appending to the output, or appending to this list, and hopefully that is good enough. Okay, of course I get messed up with...
Him calling it tail is wild. Yeah. He calls it tail the whole time. Like, I've seen a few videos of his... yeah, I've seen a few videos of his where he's just used tail as the current.
The typos, merged list.
I mean, you know, that's the type of guy that you want, to be honest, you know? You can see some of his errors and then you can, like, make your own decisions on it. And your own thoughts. So, you know, the level of, I guess the level he's at is good for you to have self-critical thoughts about the problems as well.
I guess the confusing part was that this variable name is pretty similar to this function name. Probably should have done it a little differently. Okay, but it does work, so hopefully you get the general idea. It's not too bad of a problem. There are There are actually a lot of ways to solve it, even a heap solution. But I think kind of sticking with this is fine. But thank you so much for watching. Hopefully this was helpful. If you have any tips and tricks, you can feel free to share them with me.
I want to look at the heap solution to this.
Any other problem? The confusing part was
the other part that I wanted to understand was when he did L1 tail next is L1, because I don't have that. If L1, so if none, if L1 is none, then tail next is L1, and if L2 is none, or if L2 is none, sorry, if L1 is none, L2 is going to be that thing. So that deals with the test case that I had, that I was considering before. The only thing is though, tail equal tail dot next. The tail dot next is just going to be whatever's left over of L1 and L2. I suppose. Or should I try something different, which is just if L1 is none, is that right? is none. I feel like that doesn't look right, but I feel like you can also do that as well. Okay, if L1 is none, L1 next. Car.next is L2. Or only when L2 is not none. You know? I did it for verbosity to do that, to have that, but let me do something like this instead. If not L1 and L2, and car next is L2. If L1 and not L2, car next is equal to L1. Oh. Who was that? Becca. Thanks for the follow, Becca. On the Twitch end. I get an email when someone follows me on Twitch. Just got one right now. Okay, I think that works as well. And then I want a heap solution to this, as opposed to just using a for range. So I'm gonna have to look at some solutions here. Merge two lists at a time. Okay, he still does it this way. Of log k. It's not the same guy, is it? No. Like at some point I'll learn about heaps and I'll be able to do it a heap way. Merge two lists. Oh, what's this method? If not list, you return none. Right, so just the two edge cases. At this point we know we have min2 linked lists. So mid is len list. Left is merge k lists. Right is merge k lists. Oh, he does it recursively. And then return self merge two lists. Am I right? So he actually splits it in a what do you call it again? Binary. Divide and conquer. It's called divide and conquer. My bad. Right. So it's called he does it using divide and conquer. And let's have have a look at these other ones. This is also similar. I think this is also a divide and conquer. Do we have any more divide and conquers? Nope, this one's a for loop. Okay, using heap. Using a priority queue. Let's have understanding. So why does this have to be in a language I'm not familiar with too much in? What is this, C++? Yeah. I mean, it's a 1. Do I really care if it's only 1? 1 upvote? Alright, maybe I don't care. Maybe I don't. Alright. But I will write it in the solution that we have. So if edge case lists, if not lists, and list if not list or wait. If not lists, return none. If len list is equal to 0, return none. Alright, I think those were the two edge cases. Originally. If not lists or len lists is equal to return none. And then you do the for loop. For I in range of 0 so 0 to len of lists and increment by 2, L1 is merged lists is originally equal to nothing, and then lists is going to equal to merged lists once we've done some merging. How does that make sense? That doesn't click for me yet. Yeah, because I'm not doing it right. while len of lists is greater than 1, merged lists is going to be up here. Lists equals merge lists, and this is where we merge. Self.merge lists I and lists I plus, oops, 1 given if I plus 1 is less than the len of lists, else none. And we add this new merged list into that list. This is very Pythonic, maybe a little too Pythonic. Oh well. But essentially that's what he did. And that's fine. Then we return the single list that's left over. Alright. Merged lists. Wrong answer, because we're missing 5 and 6. Those cases are fine. How come 5 and 6 go missing? Is it because of this? It could be. So I'm gonna follow the way that we did it here. So after if L1 car.next is equal to L1, else if L2 car.next is equal to L2. And we might be able to just remove this. We'll see if that makes a difference, and then I'll think about it a little harder. It does make a difference. Okay, so my thinking was off with how I did it before. Yippee! We did it. Okay, I'm gonna copy this solution into Alacrity. I'll also need to copy this into Neetcode. This problem is merge case sorted lists number 23. Insert. Oh my god. No. Yeah. Alright. This is why we got to turn off our Vim. So we can copy all of this. And then we paste it into here. Insert Control All, paste. Insert Control V. Insert Control All, C, and Control Shift V. Is that going to be bad? It looks kind of wrong. It looks wrong. Looks pretty sad. Can't believe it. Will I give a fuck? Copy. You know what I'm gonna do? Open up VS Code. Copy and paste it in that way. Unfortunately. Okay, Control Shift V. There we go. We're done. Oops. And then I can do git status, git add, commit -m. Lol skill issue. I do the same. Yeah, right. I swear I've tried it many times. Otherwise, like in something, there's something up with Alacrity, where when I try to copy and paste something into Vim from the browser, it doesn't work for me. It does this weird thing when it copy and pastes. So I'm kind of, I don't want to figure that out right now. Feet. Complete. 23. Git push. Okay, let's close that now. It's done with that. That hard problem was okay. Not too bad. With a fresh mind. So I'm happy with that. Let me submit that. Close this. Okay. Let's see, so that's one Leetcode question down, and I'm done with Leetcode for the day. Now it's time to... There's this video that I wanted to watch last night. I got halfway through today. and it's just on the box model for web development. I just ended up scrolling just now. That's not even where I want to go, to be honest. By the way, it just reached 1400 subs. I'm pretty sure it was Mr. B who got us there. So thanks, man. I think you were the latest subscriber. Or maybe it was Arcade. My bad. Maybe it might have been Arcade. Arcade. Yeah, so I wanted to go to just my history. So it was the box model.
On my DevTools, I'll open the Computed tab where we see we have a visual representation of the box model. When I hover over the content area, we see this highlights our div element. Currently, the width of our div covers the entire width of the viewport. This is because
one thing I don't like about this Slaying the Dragon is that he does a pretty strong upward inflection after every sentence, and I can't unhear it. That's just one thing. I think I've made it worse now, probably for whoever's listening in as well.
div elements are block level elements. So for example, I'll give my box a display property of block.
I'm sorry,
when I
guys.
save, we see nothing happens. Nothing happens because block is the default display of div elements, and block level elements cover the entire width of the viewport. However, we can still change the size of our div with the width and height properties. I'll remove the display of block since it's set to block by default anyways, and then under our box model comment, I'll give our box a width of 300 pixels and a height of 100 pixels.
I'm sorry. You can't unhear it now.
When I save, we see our box now has a width of 300 pixels and a height of 100 pixels. And this is also represented in the content area of our box model. Next is the padding. Looking at the padding area in our box model, we see there's no value. To add a padding, we can use the padding top, padding right, padding bottom, and padding left properties. I'll set all 4 to 32 pixels. And when I save, we see this added space inside of the box. And
Epic.
looking at the padding area in our box model, we see we have 32 pixels of padding in all directions. Using these 4 individual properties is fine. However, there's a faster way to do it using the padding shorthand property. I'll comment out all 4 padding properties and I'll add the padding shorthand property. When I give it one value of 32 pixels, we see this assigns a padding of 32 pixels in
On
all
all sides.
directions. When I give it 2 values, the first of 32 pixels and the second of 64 pixels, we see the first value represents the top and bottom paddings,
Yep.
and the second value represents the left and right paddings. When I give it 3 values, the first of 32 pixels, the second of 64 pixels, and the
I remember my lecturer showed me this. It blew my mind. That actually, right, that was me last night as well. Because I was reading an article. So this is because I was doing the Odin Project, right? I read this article, I think CSS Tricks was what it's called. I need to go to the previous. And that's where I also went like, because I finally understood some of the tricks with CSS. Where was it? Here, CSS Tricks. You know, like, I was looking at this straight away and I was like, what does this mean? And then I looked at the next line and I was like, that makes sense. That makes sense. And then I saw this line and I'm like, you can fill in the rest.
third of 100 pixels, we see the first value represents the top padding, The second value represents the left and right paddings, and the third value represents the bottom padding. And finally, when I give it 4 values, the first of 32 pixels, the second of 64 pixels, the third of 100 pixels, and the fourth of 10 pixels, we see the first value is the top padding, the second value is the right padding, the
Northeast,
third value is
southwest.
the bottom padding, and the fourth value is the left padding. An easy way to remember which value is what is to think of it like a clock. These values are represented clockwise,
Or like
with
a
the
clock,
first value
yeah.
being top, second value being right, third value being bottom, and fourth value being left. Next is the border. I want to add a border to my div element. To do so, all I have to do is give my div element the border property. The border property takes in 3 values. The first value is the size of the border. I'll set it to 5 pixels. The second value is the style of the border. I'll set it to solid. And the third value is the color of the border. I'll set it to black.
Ooh,
When I save,
thanks for the follow. Whoever that was, let me see. Mr. B. Yeah, Mr. B subbed. Let's go.
we see our div has our 5 pixel solid black border, and looking at our box model, we see that the border gets added in between the margin and the padding. The second value is for defining the line style of our border. Solid is the most common one. However, there's actually 7 others. Here's an image with all of the different line styles.
None hidden, dotted, dashed, solid, double, groove. I've seen a few grooves. Ridge, inset, outset. Man, if only I knew all this stuff in like one of the interviews that I had for front-end development. For an intern job that I was looking at. Man, if only I knew the information that I know now. The resentment prevails within me every time I look at front end. I'm kidding. I like learning this stuff.
In most cases, you're going to be using the solid option, while the others you will use in niche exceptions. Finally, we have the margin. Looking at the margin area in our box model, we see there's no value. To add a margin, we can use the margin top, margin bottom, and margin left properties. When I set all 4 to 20 pixels, we see this added 20 pixels of space outside of our element, essentially pushing it away by 20 pixels in all directions. And looking at the margin area in our box model, we see we have 20 pixels of margins in all directions. Now, just like we have a short...
Becca says, I'm scared to do interviews, never did it, too scared to. Yeah. That's okay, you know? But sometimes, you just gotta get out of your comfort zone. You know? I'm pretty sure, yeah, it's normal to be scared before the interview. I got to a stage in one of my interviews where, because there's 3 different rounds, I got to the 3rd round. But after the 3rd round, and after another call, 2 weeks later, right, that's already a bad sign if they're telling me the result of my interviews 2 weeks later, that I was rejected. Well, they didn't say I was rejected, but they just didn't have room left. They told me if I had applied for the internship 2 years ago or a year ago, I would have had a better chance. I think that's because of the also because big tech companies were hiring a lot. Like they were on a hiring spree. So that would have made sense. I feel like I would have made it in then, but I decided not to because I didn't even think about what internships I really wanted. And when I actually go for internships now, there's a shortage, and I'm among the not the top, I suppose. I mean, for context, this was an internship interview. This was an Atlassian interview for their internship program. To be honest, would I really learn all that much in 12 weeks? I will. But with that rejection, you know, I'm starting to learn a lot more about web development to make myself more employable, and also doing Leetcode more, you know?
Hand property for the padding, we also have a shorthand property for these 4 individual margin properties. I'll comment them out and I'll add the margin shorthand property. The margin shorthand property functions exactly the same as the padding shorthand property.
Oh, wait. I have a lecture in 3 minutes. Oof. Let's see. CVCS. CS is what it is. We need... lecture capture. So today's 23rd. Yeah, so it's coming up. Can I finish this in 7 minutes? Maybe.
We give it one value of, for example, 20 pixels and save.
Becca says, what year are you in? I am past my bachelor's. I already did my 3 years. And now I'm doing my master's. So I've got a master's coursework going right now. First year, semester 2. I started semester 2 just yesterday. So, yeah, you know, it's coming along. You can watch the lecture if you want, but it could be boring because it's introductory stuff. So, I expect a dip to come when I start watching this lecture. Dip of viewership, I mean. Becca says, oh, good shit. Thank you.
We see this added 20 pixels.
I'm still iffy about my choice of doing a master's, to be honest, but we'll see. I start 4th year September. Epic. So you're not too far off. You're not too far off.
Of margin in all directions. When I give it a second value of 40 pixels, we see the first value is for the top and bottom margins, and the second value is for the left and right margins. When I give it a third value of 100 pixels, we see the first value is for the top margin, the second value is for the left and right margins, and the third value is for the bottom margin. And when I give it a fourth value of 500 pixels, we see this added 500 pixels of margin on the left side, because when we use 4 values in our shorthand property, the values are represented clockwise, where the first value is the top, second value is the right, third value is the bottom, and fourth value is the left. I want to clean things up, so I'll remove all the properties I commented out, and then on my margin shorthand property, I'll set it to 0. We see
they don't tell you how much writing is in CS course. Holy shit. I mean, it depends, right? I mean, to be honest, it really wasn't that much writing for me in my bachelor's. Apart from writing code, right? I only took a few subjects that had me write essays. But now that I'm in a master's coursework, there is a lot more writing essays. Or, you know, research papers or research like reports. And those are like essays, right? So I guess that's a piece of advice. Pick your poison, do a master's or not. To avoid or to do essays. I only figured out that you're writing a lot more in masters this year, you know. So, yep.
In the viewport and our element. The reason this is happening is because if we look in our developer tools on my elements panel, I'll select the body element, and then in my styles panel, I'll find the default styles that the browser automatically assigns to the body element. You see, on the right side of this rule set, it says user agent style sheet. User agent style sheet.
Hold on, hold on. That went a little fast. Maybe I will slow it down.
Margin shorthand property, I'll set it to 0. You see, despite our box having a margin of 0, there still seems to be some space between the viewport and our element.
Yes.
The reason this is happening is because if we look in our developer tools on my elements panel, I'll select the body element, and then in my styles panel, I'll find the default styles that the browser automatically assigns to the body element. You see, on the right side of this rule set, it says user agent style sheet. User agent style sheet means the default styles that the browser automatically assigns to each.
Let me see this. Body styles layout computed. I'm guessing these are the styles. User agent style sheet. Filter styles to body maybe. Margin 0. Probably I can't see it because, I mean, this is on YouTube.
HTML elements. We see on Chrome, which is the browser I'm currently using, it assigns a display of block and a margin of 8 pixels in all directions to the body element. This is the reason we currently have a gap between the viewport and our element. To fix this, what I can do is select the universal star selector and give it a margin of 0. This is a reset that I always add before building a website. And all it does is it removes all of the margins on all of the elements that automatically ships with a margin. And we see with our margin of 0 on the everything selector, the gap between the viewport and our element is removed. As a side note, you should make sure that you create this rule set at the top of your CSS file for specificity reasons, so that you don't overwrite the margin you purposely add on elements like the margin we're adding on our box, for example. Furthermore, while we're at it, we can also add the padding of 0 on our universal star selector to reset the padding on all elements that automatically ship with some padding. This is also a common reset I add before building a website. By now, you probably understand that the box model is just a name that is used to refer to the content, the padding, the border, and the margin. Content, padding, border, and margin together is the box model. However, there is something quite annoying about the box model. If I were to ask you definitely what is the size of our div, you would probably say that our div has a width of 200 pixels and a height of 100 pixels, like we defined in our CSS. However, this is wrong. When we give a value to the width and height properties, this defines the size of the content area in our box model. We gave our width a value of 200 pixels and our height a value of 100 pixels. And looking at our box model, we see the content area has a width of 200 pixels and a height of 100 pixels. However, the content area isn't the entire div. Both the padding and the border are inside the div. Only the margin is outside. And because both the padding and the border are inside our div, we need to add them up to figure out what's the actual size of our div. To demonstrate, I'll set my padding to 16 pixels. And now, our content area has a width of 200 pixels, our padding has 16 pixels on both the left and right sides, and the border has 16 pixels on both the left and right sides. To figure out the actual width of our div, we need to do some math and do 200 plus 16 plus 16 plus 5 plus 5, which equals 242. Our content area has a height of 100 pixels, our padding has 16 pixels on both the top and bottom, and our border has 5 pixels on both the top and bottom. The math for this is 100 plus 16 plus 16.
Okay. It's already 11:05. I will pause that. Gotta watch that lecture now. Goes till 1 p.m. Ain't got time for that. Yo, why is it frozen? Why is it actually just frozen? Today's such a good day as well.
Today you are here all for cryptography class, right? Yeah. I think still people are not coming to the campus. I think one of the things that trying to do is to get more people into cameras. Actually, for this subject, it's quite important that you attend lectures and workshops. But anyway,
Well, I'm not there in person.
subject today, what I'll do give you a subject overview, the first part, and then I will introduce introduction to cryptography. And the subject is about cryptography and security. And so there are issues about security that we learn throughout the lectures, like throughout the weeks. So you would have heard how security is important. For example, you can see that the Windows on this computer is still not functioning because of the attack that you'd all heard about, right? The news. So you can see that security is
Wait, CrowdStrike affected our uni as well?
So this subject is about cryptography and security.
That's
So
funny.
in some sense, you should have the right questions to understand this topic. And so it's a quite broad topic, but cryptography is a quite very specific mathematical object that we're going to study. Okay. So I'm going to give you a subject overview first.
CrowdStrike affected everything.
Sure that how many
Yeah.
of you have already gone to the workshops? Can you raise your hands? Yeah. As you can see, compared to other subjects, the workshop starts from week 1. So the main reason I have decided to do a workshop itself is so that you could make
Oh, I gotta sneeze.
some rapport with your tutor and understand what are the things,
No, I'm good.
what are the things you need to do. So, and also start learning about numbers. Compared to other subjects, you do learn something basics here, and also you will also work on protocols. So in some sense, so that's why to make this point very clear,
I can't hear him now. It's so hard to hear him. Come on, the 8 people. Let me turn it up from my
so
dial.
yeah, I mean, it's a cold morning, but I think it's a beautiful morning this time, right? Compared to last week, it was
True.
raining, and now
Valid.
it should be better. So please open up, and we'll have a discussion and conversation in this subject. Okay. Pardon me, I don't know. Yeah, a bit of a cold. Okay. So
Nicolam Dev, what resolution is your monitor? 1440p.
So my name is Udaya Parakali. I'm a professor in the department. I research and teach this subject, computer, networks, cryptography, and some other topics and algorithms. So I've taught various computer science subjects in the department from the last 20 years, more than 20 years. This is the team. So Jenshi Lei is our head teacher, and then a couple of mainly Muhammad Aditya Helmi and Sonia Lakshmi Lakhani are the tutors, and there are of course a few people who help you in the marking. So this is the kind of tutorial team, and there are about so at the moment the two tutorials.
I'm gonna stand up.
Like
Give me a second.
bring your attention. What usually for the the strength we have this semester, we need around 7 to 8 tutorials spread throughout from Monday to Thursday. And I closed some of them early ones. You probably don't want to come at 9 a.m. right? But however, for some reason,
For some reason.
and so today, for example, there are 17 or 13 people enrolled into 9 a.m. Only 3 turned up.
Only 3 turned up to
So
17 people or
obviously
9 people.
The 9 a.m. is not very popular.
9
Do
a.m.
you
is
all
not
agree?
popular.
Okay. So, I mean, I have lots of other things open. So, we have balanced it. And so, since yesterday evening and today morning, we have closed 5 of them, which has been
Ooh,
there
thanks
are
for the
others,
follow.
available. For example, on tomorrow there are 2 already full.
Wait, who is that?
Increase their numbers. So at least you should be able to do.
Thanks,
Monday, there are still
Nicola.
lots of
Nicola M.
places available. So,
Thanks for
so
following on
if
Twitch.
you're not, if you are on Monday, if you're not attending, I advise you to go to any other workshop today and, at least get the material from the tutor, work through it and start working on it. And also reflect, and there is a quiz available, reflect on whether this is the subject that you want to do, or you want it to delay until your 3rd semester. If you are 90, sometimes this can be 2nd semester.
Rose telling us to defer a semester.
Come up with the later, that's also fine. But you have to make your conscious
Just because it could be difficult, right?
subject that you want
It's fair enough.
to learn. Okay? So while lectures are recorded, so if you, for example, occasionally miss a lecture or something, you may be able to.
How many people are in this actual class? That's a good question.
But workshops are not recorded, and so which means that you have to go and attend workshops. So if it is not recorded, means you have to make conscious effort, go there and follow it. I would like to tell you from the experience I've had in this subject. There are subjects where you can go to any week and listen to a lecture and get something out of it and maybe learn. Whereas the subjects now, because we have the values and some other type of they all built on learning. If you learn one thing and this will be in learning. And so a constant learning is very important. So if you miss particular week or 2, then it's not that it's not come back.
Have to go to sleep. Good night. Have fun lecture. All good, man. Go sleep. Probably sleep is better right now
Then you come to the lecture,
than just watching me. So yeah. Good night, man.
the previous lecture.
Woman or whoever.
I mean, so, then slowly not coming to a workshop. But lectures you can watch, but workshops are not required. For the privacy reason, you are actually learning from there. So make sure that those who, even here, so in the past, about 5-6 years ago, my first class will be full, almost 80 or 90%. But look at here now, I only see about maybe 40 or 45%.
40 or 45 people.
So, I know after COVID-19, you may think that it's but remember, when you say that, what actually done now?
That's true. Bro speaking facts. Good life. Good life advice. Mr.
You may make some note. Okay, I need to.
Udaya, I think.
Subject part of it. That's okay. But being here, having heard once, will have some impact on the way you understand and study. Remember how you learn.
The 8 people on this stream side-eyeing.
What happens, like a very simple idea. First you hear, then you think about whatever you heard you start thinking about it, and then you work with examples. So you work on it. So basically, first you hear means connections, and that will be there.
Yep.
So even if you have not followed a particular, let's say an idea, lecturer says in a class, but if it is already there, the information is there, but next whenever you go in this subject line, if you are enthusiastic, we are enthusiastic. So, I mean, I'm
Oh, the
already
internet's
talked about
back.
something's a little bit of
Yeah, something that we have at home is internet cutouts, so
apart from I teach
my bad to those who are listening in.
also now take care of
I gotta repair my Bluetooth headphones.
and of course we will have an occasion to touch about quantum computing because cryptography that we're going to do in coming years is completely transformed or changed because of the quantum computing things. And I'll just probably in the first lecture I will just briefly mention, but those of you interested, you'll have a lot of opportunities to explore. In fact, a big area called post-quantum cryptography, and that's very important. And I'll just talk about it when I think. And other research interests are whichever, for example, my own interest is in pseudo-random
Hello,
numbers,
Rulpon.
basically random numbers,
Nice for you to join.
zeros and ones. So
I'm watching a lecture right now,
some of the work I
and every now and then my internet's cutting out randomly, so I'm sorry if it cuts out for you.
about pseudo-random numbers that has some good correlation properties. But how do you distinguish a particular sequence from other general random numbers? So in that category, these are basically these equations are used for coding black communication. So for example, I mean nowadays you don't hear that much because whenever you have a mobile phone, you are already connected to the base station. Whatever the base you want to code, you can say, so much of technologies are already people taken care of because it's already there. And one of the such access method is by code division multiple
It's
access.
fine. All good then.
Because if multiple users want to access
You're doing like a coding class thing? This is called cryptography and security, so yeah.
code division actually works with simultaneously everybody will be able to access by accessing a code, and each code is designed
And he's just talking
such
about
that
like some
each user
theory.
can easily distinguish
He'll be talking
and
about it like
correlate
throughout today and stuff.
code between any two are small.
Up until
This
1
way,
p.m. by the way,
you can actually design
which is like an hour, 2 hours.
communication system. And out of that, the course
And I think he's talking about his own research
and
interests right now.
more about it. And
I don't know, I've been cut out for like a minute or two.
is making use of such fundamental objects and design a better system, for example, steganography. So you can use this same kind of code,
Steganography.
and also there is also about the designing good protocols for communication and radar and other stuff. And you can the same type of things or idea for also DNA storage of DNA, like DNA storage, so all the coding theory that comes in. So you would know a bit more about that from the things that I want to spend more time. So precisely, how do you contact me? Before we're at the end of the lectures, if you have any questions for that.
Sure.
Otherwise, you can email, and I'll get lots of emails. So whenever, if you are really asking any questions about Comp 9043, please put Comp 9043 in the subject, and I would try to return you as soon as possible. Okay. And we work in Melbourne Connect.
Oh, wow, is it still daytime for you? 9:22 p.m. for me. Yeah. Well, I live in Australia, so
Just to briefly describe
it's
the
daylight
structure
right
of the
now.
subject, and that also will tell you about what are the assignments, expectations from you, and any questions in this. So the lectures are 12 weeks of lectures, and
It's
you see that
yeah, it's 11 a.m. right now for me.
has 2 lectures, and the first lecture is of 2 hours, right? And it's done intentionally because the idea is that 2 lectures with a maximum of 3 hours per week. sometimes
maximum
happen,
of 3 hours per week.
This 3 hours as a lead I guest lecture or initial mathematics, and hence so I've added, but roughly
I see.
over the things, just like any other subject, you have 2 hours of contact, but you would have a little more based on sometimes for covering basic mathematics or covering guest lectures.
Yeah, covering basic
Assessment
mathematics.
Is a very thing.
I covered that yesterday.
Test.
I'm
This
still
time
stuck on
we
some
will do it
butts.
at week 6 itself. It used to be done week 7. Now we have changed a little bit this time, but we want to actually check how you are going in the subject as soon as possible, so that you can have some kind of a sit back and decide. Oh, okay, how I'm learning this subject. Is it really for the subject or not? So that mid-semester
Mhm.
festival is scheduled for week 6 on Tuesday. I've got all the confirmation for the examination. It will happen during the same time as here, but it will be in different place. So it will be like an exam. So you will write using pen and paper, and we will check actually how you have been learning in the subject. And the second part of the assessment is 40% final exam. It's a 2-hour final exam. Okay, and for the mid-semester there is no hurdle, and for the final exam there is a hurdle. And there are 50% is project assignments. 2 project assignments is two assignments. Assignment 1 and 2 is 7.5, and about 1 group research project. It's about 35%. This will be related. The results I'll give you a bit later. But this has 2 parts. So on week 10, your group will present. The group can be of size 1, 2, or 3 maximum. And there will be a presentation on week 10, and the delivery of results report on week 12. Now we have some interesting is comes about the things, and again these assignments. Also there is a let me come back to that here. About to pass the subject, student must obtain at least 50% overall, 50% in homework assignments, 50% in research projects, 50% in end term written exam, and no hurdle for the mid semester. That's all kind of thing. So come back here. I want to give you just to kind of encourage. So there is there are some online weekly quizzes. So every week there will be quizzes. So it will be around 10 online quizzes. And if you do, kind of you have to do everything. Like you should, because these quizzes you can attempt as many as you can. So you should attempt, make sure that you get 100%. And then if you keep doing this assignment, you get 1 bonus marks at the end. Okay.
What?
Now, and also tutorial attendance. It's very important. So if you just go to tutorial attendance and interact with the tutor, make sure that he knows that you have come there. And that's it.
Retro says, are those classes live? Yes. I'm watching one live right now. I just hope my wind doesn't cut out the internet for too long, so that I miss information.
But keep going to the but of course these bonus marks will only go towards the assignment. So 2 assignments will have 15, and that's where you learn materially. So even if
This guy's alright. It's just
the bonus marks will only go towards assignments, not to anything. Okay.
I think he explains stuff okay, but sometimes he overlooks some proofs, in the sense that it's hard for me to understand.
So this is
Ooh,
what because I think the main
Who was that?
I went through the feedback from
thanks for the sub, Rolfan.
here.
Rollpon.
One of the things that what I found was basically
Appreciate it, man.
weren't going to the tutorial, and hence they find it the later topics were sometimes conceptual for a lot of so usually we have and the material for this week will be these books.
Damn cryptography, which year are you in? in my 4th year, you could say, except I finished my bachelor's and I'm doing my 1st year of master's. And this is, yeah, a specialization subject. I think it's still giving life advice.
That's the kind of things. About 10 online quizzes and about 10, 11 tutorial attendance. So even if you miss one or two occasionally for some extreme reason, there will be some provision for those kind of things. But generally, if you've been attending, you can get these kind of things. Yeah.
Let me make this bigger.
Pretty clear. So research project is about a group project. It's a group size maximum 3. We'd prefer groups of 3, but it's up. You can give somebody one because in
Group
cryptography,
projects.
sometimes you get some very good students thinking they want to think alone. So we allow even if you want to do project yourself, it's also good. You can
Really?
so 1,
Okay.
2, and 3. And project should be based on a topic that involves cryptography. You can't do any. It can be security, but there should be a cryptography involved in it. So a list of suggested topics will be available at by the end of when you have finished with assignment 1. You should organize your group preferably with members in the same tutorial group. That will help you. And
There are a few good ideas.
Contact for any of these things. So you need to choose a topic and propose a topic for such a...
Retro says, nice, nice. I'm still doing my bachelor's, currently in junior year. Mad.
First you show your intention and you...
Keep on doing it.
I want to do this. That's the intention. Proposal is also...
Keep it up.
part in the project. And then body of the work has some implementation, problem identification, analysis, and approach. So
I'm guessing like 1st or 2nd year of bachelor's.
clear-cut marking policy, how we see at the and look at the marking policy and how you get the maximum.
Yeah. Nah, 3rd? Okay, good. Yeah, I'm seeing a lot of people in their 3rd year come to chat. So, it's nice. I guess I'm just picking my target audience to be 3rd year computer science majors.
For example, develop this idea, and you don't need to do the original. It can be based on something. You have to cite the work properly and do that. So we'll talk more about when we release it, but this is general things, and that's what is expected. And usually, what I found in the past, this research project is the one which that is where people maximum interact and work and they love this work, and that gets you about 35% of the mark on this.
Sure.
So this is the hurdle that I've already explained. So these are
The internet.
You may have some guest lectures and revisions to some lectures. Yeah, contents of some of these may be examinable. Yeah. So for example, if there are some guest lectures by industry experts on cryptography, they will be examinable as well. And the typical subject resources, we follow the textbook on cryptography and network security. But for most of the cryptography topics, I have developed all the slides and we have developed the material. So if you really work from the workshop material and the lecture material, that should be what you don't need to really extra thing. But
Retro says, any advice on how to get some nice internships?
library as well. And
Good
there are a
question.
couple of references. Really, if you want to
I would say just... Ooh.
know more about cryptography.
Wait, I probably cut out there for half a second.
On cryptography, Stinson,
The frickin' wind! So sorry about that. But how do I get nice internships? Just go to Grad Connect. You know? At least that's what we do in Australia.
And the basis of methods from modern cryptography. So modern cryptography has changed a lot. I'll explain to you what
Computer
is
science.
cryptography and other things in coming. So we will concentrate on topics that are current interest as well as more practical.
Internships.
So basically, when you have topics that are drawn from symmetric key cryptography, hash functions, authentication.
Anything that you see here, that's what I use at least
These are the
to find good
and
internships.
this will cover. These are the
Personally,
foundational part of any
I haven't picked one up myself
cryptography-based
yet,
system. And you can see.
but I've had like past
The
experience
objective of
working
this
at a
lecture
job.
is for to understand the fundamental security principles in modern computer networks and computer systems, be able to find the protocols which ensure security in the contemporary systems, and to study various cryptographic primitives. So I think the main content would be to study the various cryptographic primitives and what are the problems of this primitive, how
Okay.
to bring the security objectives.
Security principles, modern networks.
So that's a kind of a thing, and we have a course plan, and roughly every week is.
Introduction to cryptography and security, introduction to numbers,
So that's what I'm saying. So each
symmetric
idea takes time
ciphers.
from one week to another. It is important
Yep.
that we study start from the week one itself. So these are some general skills, and that's the plan of the of this one. Okay. Do you have any questions?
Ooh. You have an interview lined up for Google tomorrow. Any advice on that? Really would appreciate some. I would say, I mean, I'm not the best to get advice from here, but definitely just think about the problem in context to, I guess, the business problem, right? So, do we really need O of n efficiency for this type of problem, for example? And just ask the interviewer that type of question, because that shows that you think about the question in terms of the business perspective as opposed to just the coding.
Okay.
I think that's my one advice to give about that.
So this will be.
But good on you, man, for getting a Google interview lined up.
I will cover some part.
It's mad.
With the break, and then we will start. First one. So this is about introduction to cryptography, and this particular lecture has 4 parts. First part on general principles of information security, for some definitions, roles in cryptography, etc. And then we'll look at some motivating examples and some classical examples, and then some security objectives. Yeah. Okay. So what are the definitions and the role of cryptography and separation? What is cryptography? This is the
Oh, good, man. Thanks. I'll let you continue Leetcode. To continue your lectures, go to Leetcode some more. I respect you for that, man. Keep on Leetcoding.
why these are there? Basically, all because of the open and growth of real security. Internet technologies, how the internet technologies are designed initially in the first place. So there are potential places, how does the internet work? Most like a postcard. So when you have a postcard, when you post it, obviously whoever who has it can easily see the material inside, right? So whatever the so in such things now we want to make this when you go to the web and you connect to the bank and then you go to communicate with the bank and present yourself your credentials and ask the bank to transfer money from one account to another. All that you could do sitting at your house, on a computer or on your phone, but the bank is somewhere that you can pay the server. So how does that work? So this is for back on the node, and we make that such a thing. You don't have any technology. How do you design such a thing? I don't know. Have you gone to any teller in a bank to know where I think nowadays most of the time you don't go to the bank. They also don't want you up there. Most of the time they go out. So you don't really how to do it the bank. What you can do is that
Autonomous. Yo. One such method. Confidentiality, integrity, and availability. Damn.
Using cryptography. So in the field of network and information security, Starlink take. Starlink is William Starlink is a famous
Starlink's
security
take.
consultant. He has written lots of books and a very influential person in the field. William Starlink, who wrote this book, it's a very nice book, and so I chose this because even though I had mathematical, I would have liked some other book, but this is much more appealing to broad audience. So the field of network and internet security consists of measures to deter, prevent, detect, and correct security violations that involve transmission of information. That's what Starlink's take. Now, our approach in this subject is to study certain basic cryptography primitives such as symmetric and public key cryptography, hash functions, message authentication, and signatures, and use them explore the field of network and internet security. So we first, so from the security we kind of a bottom up. We learn what is the symmetric cryptography, what is in a public key cryptography, what are the hash functions, tag, and other message authentication, signature. So these concepts we learn how to understand how to and based on that we will actually how to for example, how to make secure, right?
SSL.
And so that's a kind of approach in the subject, cryptography and security. Okay, study of cryptography. So now a couple of slides. I don't want to bore you with many things. So this particular type of animations are there in any cryptography topic. When I studied here also so some story of cryptography. So Alice and Bob. So these are so these are not just fictional characters for us. They are have a special meaning. Alice is public key. And Alice is an identity.
Yeah, I'm gonna go into the in-person lecture next time. The only fact is that this is the only lecture that I'd have to go to on that day.
They want to communicate. But the problem is, Eve is there and can see this information. Because in those days, what we do, you write it on a paper and try to communicate with somebody, and Eve is befriended with the person who is taking this message. So Eve can actually look at it. Now, how do you secure? How do you achieve that security? So in the ancient time itself, what we do, so what Alice will do, Alice and Bob, they have some kind of encryption that takes a key and the message she wants to communicate with Bob and convert it into ciphertext, something that even if Eve gets access to that particular message, will not be able to make sense because it will be some gibberish things. So for example, let's meet in the alley, that's the same.
That's all good, that makes sense.
So the main idea is that Alice and Bob know securely the key, what key that's they know, but you will not know that. And they said that this and Bob will follow approximately other algorithm. He will take the decryption function and apply the same key and obtain that. But the next question is, how do they agree on the key? How do they get the key? So for that, they should meet in private. So without meeting in private, they are not getting it. So if you get a key, you get a security. If you don't have a key, you want to answer the security. But if you have a sexual communication, you will get
Right.
Even though they may not be able to, Alice and Bob may not be able to openly, but occasionally they may be able to use secretly at short time, and where they communicate the key, and then other times they can use it. So this is, for example, this so this particular lecture can be done for the whole lecture actually. I mean, you can see some books written by Simon Singh and others from BBC writer. It's a very large book about the ancient days, how security was done. You know, for example, King of previous time used to send some information to other people what to do. And in this subject also, in the next week, we will learn about the classical cryptography methods. So this is the model. Is that clear, the model? This model is very important, even though it's so obvious and it's so clear, but actually this is the model that was used until even last century. The same model was used for security. Even when Germans, they built their big missions, Enigma missions during World War II, the model for such communication is this one. Now, fast forward in modern times, what has happened is the communication link is now being replaced by a big internet, and the Eve now can be anywhere on the internet. So in fact, the service provider itself could be an adversary. So so in this case, Alice and Bob now cannot meet in advance in any situation. So now, for example, in this modern day situation, fast forward, Alice and Bob is now connected with the modern network infrastructure. Can you help them to find a way? And in this case, what we do is mathematics come to their aid. So the magic tool in this case, what we introduce called one-way function, we'll consider many such one-way functions based on in this subject. So in general, story of Alice and Bob in terms of notation. So you can think of how does the security with the encryption works. So you can see in the model we have an Alice, the sender, and you have a Bob, the receiver, and you have Eve is an adversary in somewhere on this internet. Okay, and so you have a message M. Sometimes all these names are also very important. We call something called, if it is unencrypted, it's called plain text. If the text means a plain text, but if it is encrypted, it is called cipher text. Okay? So it takes an encryption key, and it could be both public or private. We will come back to that. And then we have got an encryption key, and we have a point here, in the network where the eavesdropper can find. And then once the decryption box, you have a decryption key, and the Bob can recover the message M dash, provided he has the right decryption key for the encryption. So depending on the way we define encryption key and decryption key, we have different kinds of crypto systems. So this model is pretty important. So, but in this model, the encryption function and decryption function are public. You can't make some, my own specific encryption function. Yeah? That kind of approach will not work in this one. So cryptography involves many such conceptual ideas, and we look at some of the basic functions. Okay, so and there are differences. If the encryption function and the decryption functions are same, sometimes they are called symmetric key system, And this is something known since antiquity. And if they are different, then it's also called asymmetric encryptor system. And that was, first time that was actually taught in 1974 by celebrated team. We'll talk about that. I've also added this paper in the LMS, so it's very, very important you go through and study them. Yeah, study this paper. It's very interesting. So one of the. So now, before going to the next section and have a break, and I want to kind of just allude into the some of the modern developments in cryptography, especially what's going on now in last few years. This one is so in fact you can see, I think all these are happening because also there's quantum computing. How many of you heard of quantum computing? Oh, lots of people know about quantum computing. Do you know how it works? Some physicists have come up with some idea. It's definitely completely a different way of computing certain things. Right? It's not like classical, right? But and this also gives sometimes new ideas of refinement, but where with this quantum computing, you can solve certain problems much faster. For example, all the things that we learn in this subject can be broken. Like the whole security of this is broken. Just a moment. So people learn each other things how this So how much that happens But before even to understand that, first we need to understand the actual cryptography, and the whole subject is about that. Okay. We'll take about a 5 minutes break, and then we will.
5-minute break. All right. Mad. Love a 5-minute break. As such, we will continue on with this.
Plus 5 plus 5. This equals 142, expanding the side and the border. Therefore, the width and height of my div is 300 pixels by 100 pixels. We can confirm this by calculating 258 plus 16 plus 16 plus 5 plus 5. This equals 300. Border box is what you always want to use. You pretty much never want your elements to have a box sizing of content box. Instead, what you want is for all your elements to have a box sizing of border box. And here's 2 important reasons why. First of all, by using border box on all your elements, you'll always know the actual size of your elements without needing to do mathematics to figure it out. Whatever you set on the width and height properties will properly represent the actual size of your element. And secondly, some elements, like the button element, for example, has a box sizing of border box by default. There's also other elements like the table element, the select element, the input element, and a few others that by default are border box elements. If you don't set everything to border box, you'll have an inconsistent mixture of elements that either use content box or border box by default. By setting everything to border box, you'll have a predictable way of knowing the size of all your elements. And even more importantly, you'll have consistency in the behavior of all your elements. Now the question is, how do we tell all our elements to have a box sizing of border box? Well, instead of defining the box sizing property on individual elements like what we're currently doing with our div element, what we can do is remove the box sizing property from our div element, and in our universal star selector, give a box sizing of border box. When I say, you see, good. Our div has the box sizing of border box, and if we had other elements, they would also have the box sizing of border box. Now, although defining the box sizing of border box to everything using the universal star selector like this is fine, there's a more popular way of doing it that ultimately makes sure that 100% everything gets the box sizing of border box. I'll remove the box sizing of border box from our universal star selector, and above it, I'll reselect the universal star selector. However, this time, I'll add a comma, star selector with the before pseudo element appended to it, comma, and star selector with the after pseudo element appended to it. Inside the curly braces, I'll give a box sizing of border box. This is the proper way of giving all the elements the box sizing of border box. This will make sure all our elements, including pseudo elements, get the box sizing of border box.
Wait, hold
That object would have the
on.
box sizing of border box, and if we had other elements, we would also have the box sizing of border box. Now, although defining the box sizing of border box to everything using the universal star selector like this is fine, there's a more popular way of doing it that ultimately makes sure that 100% everything gets the box sizing of border box. I'll remove the box sizing of border box from our universal star selector, and above it, I'll reselect the universal star selector. However, this time, I'll add a comma, star selector with the before pseudo element appended to it, comma, and star selector with the after pseudo element appended to it. Inside the curly braces, I'll give it a box.
Let's speed that down.
I'll reselect the universal star selector. However, this time, I'll add a comma, star selector with the before pseudo element appended to it, comma, and star selector with the after pseudo element appended to it. Inside the curly braces, I'll give it a box sizing of border box. This is the proper way of giving all the elements the box sizing of border box. This will make sure all our elements, including pseudo elements, get the box sizing of border box. This is a reset I always add before building a website. I would never build a website without this reset. This is probably the most important reset you can have on a website. If you enjoyed this video, please consider giving it a like and hitting that subscribe button.
He called
I know
it
pretty much every
pseudo-box?
YouTuber says this, but liking the video and subscribing really does help out the channel a lot. And it shows me that I'm doing something right with these videos. Also, if my way of teaching resonates with you, do check out my full CSS course. The link to it is in the description of this video. Thanks for watching.
Maybe just right. A little too many inflections in the commentary, but otherwise very good and detailed explanation on the box model. Thumbs up. I'm not gonna bother. I think we're back.
All right. So we'll start again. So let's look at some motivating example. So here, the banking example that I mentioned, you can see that in the browser, you will be able to, for example, this is browser is the account bank application, and the server is somewhere in the back, right? Now, and you can actually have a browser on your phone or a laptop or any computer. So this is a autonomously system anywhere can be there. And how do you get money from the bank? Now, this should work over internet, kind of thing. So think, in this case, who is Alice? Bob and you here. Okay? So now, Alice could be the browser application here, the endpoint.
Yep.
Bob could be the server.
Yep.
And Eve could be anywhere who is on the internet, who have access to the packets, the information that's being sent from browser to the bank. So what tools cryptography can provide, obtaining this? So for example, whatever the information you input here, maybe including the account number, everything, that should be only visible to the server and nobody in between. So as soon as you have open a browser and connect to the computer, you should have some kind of a secure pipe that going from the browser to the server. Now, how do you create such a secure pipe? All the information follows through the secure and it is not visible anywhere in between. Now, to understand this, how do you create it? This is what keep thinking about this project, this problem, and to introduce that,
Sentry SDK.
I will slightly generalize and introduce what is called a general communication game, protocol game.
Communication game.
Let's try to understand. So in this particular topic, it's a laid-out topic, but where you will think how to do this topic, right? Alice and Bob here, they are very busy students. So they are friends, they live in the same city, maybe different part of the city, but they are very busy students. And they want to spend some evening together. And they want to decide to go to a music concert or a cinema. And they can resolve either way by talking. If they were here, together they can talk fine and based on the way of money, you can find their hey, go to the cinema, find the star, I will go to the concert. That is easy. But unfortunately, they are now in two different parts of the town, and the only thing that they have is telephone, nothing else. Okay? They have offices by the telephone, and they need to book a program in advance. Of course, they are going, they can leave in the evening and talk about morning before the office starts. So can you help? The only thing available is telephone.
How can we help them?
made out problem, and I want to really very in a hurry to introduce one-way function, I would do that, because I have an objective. I have to start my course. Yeah. So so here let's say that I have a. To help me further, I give it here. I assume that we have a magic form. Every integer x, it is easy to compute f of x. Just take x and push f of x, it is easy to compute f of x. However, given the value of f of x, somebody has given the value of f of x, before it is So you can see that how it becomes interesting, because after that, when you have a practical internet application, right? It's a practical one. So here is an application. So here is a protocol. See whether this protocol makes sense and whether you agree with me that this protocol is. You have Alice. She's an convey that information over to you. Now Bob, he can't get what X is, but he will guess X is even or odd. He will tell immediately X is even. Now, so basically so somebody is, this is equivalent to Alice tossing at her head, and the Bob current is odd or even. Okay, it's different. How the tossing done, right? The tossing through this function. Now, so this is even or odd, and then after Alice gets the Bob's guess, she will now reveal her X. Now Bob can verify X equal to f of X, whatever the name is. So whoever this is again will set the value of the day.
Can you modify so that both values?
So you want to have unbiased. So can you modify this protocol where both Alice's and Bob's choices matter? Both choices are indeed used. That means one cannot get advantage over another.
Hmm.
Think about that, and you can work through, and solution will be there. Yeah. Basically, you can repeat both of them, both sides, two sides, and choose XOR of the input, whoever was the input. But you can come back. We can discuss that later. Yeah. So you also kind of and somebody said actually if the line is secure or not, you can assume, but there are cryptography you can use it to make line secure. And also you got different methods of communication where intruders cannot reach the channel. So we'll discuss cryptographic solutions in this course. So traditional communication model allows that Alice Bobs is connected by insecure channel. Marvin adversary can listen to their conversation and modify if needed. In the modern network model, network itself is adversary and more than two participants, and a valid participant can also be an adversary to others. So for example, when in a modern network now, each person, even a valid person also could be an adversary to others. So we have to, modern network security is an important one. So if the line is, did that, so basically one-way function, thinks about is, does one-way function exist? So this is a simple question, raises lots of philosophical issues. Cryptographers would like to believe that they exist and have come up with many practical one-way functions. Do they have a clear-cut proof of this one? In fact, on the other hand, this is still is not really clear. And if you have a proof that there exists a one-way function, then we solve a lot of problems. We can have a secure encryption of order. We don't have at the moment a clear-cut proof in theoretical computer science. If you find one, that is an important thing. Also, but on the other hand, what happens in the present day game is cryptographers would like to believe that they can always find cryptanalysis will believe other towards this. So all that is in general. That's what's happening. So for example, we have AES, an advanced encryption standard that we learn in the subject, as we get to know. We don't know whether it's secure or not, but we know that many active cryptographers are not secure. So we assume that it's a standard, it's not breakable, but we don't have a proof that this is secure. Okay. So same way too with many of things. It's very interesting, and sometimes all our human technologies are built on our own trust, like whether they do. So this has a lot of philosophical implications as well. I will now go through a classical example. This is something that is a thing. So here, this is about the Diffie-Hellman. So in 1976, these two gentlemen, Diffie-Hellman, they gave a paper. They wrote a paper that changed the way we do cryptography or communication. This is something that very important milestone that happened in the 1970s. I'm not even at the moment you probably take care of it. So the problem that Diffie-Hellman was trying to solve is this: there are two users who want to share a common secret over a public network. So you have a public network, and two users want to share a common secret or a public network. That means everybody is watching. I want to share a common secret. Is it possible? So in a Shannon's communication theory, for example, you have a bits communicated over network. Whatever one says, everybody can say. So now that was a problem. I don't do that. For a moment, assume that we have one-way function. Let's say what I want to go through in these couple of slides is what was happening in the minds of these Diffie-Hellman at that time when they come with. If you also get the same idea, it's almost as powerful as you come up with that idea. So this is what they did, and when they did it, they become quite famous now. So let's see whether we can come up with Diffie-Hellman protocol. So what is a one-way function? So given x, given a number x, it is easy to compute f of x. So we know how to computation, we know how to, you have gone through the algorithm. Take input x, make some modifications. I mean, if you have a set of instructions, what it ends is f of x, and if you can actually write down in a polynomial time, it is easy to compute. So it is possible to think of that kind of thing. But what you do is that when always x go from one value and f of x, so for example here, just to give you some idea, I will document the camera too. Okay. See, so you have, say, if x can be, in some domain x, and f of x can be some domain y. Okay. So x can be 0, 1, 1, 0, just like you can a set of things, but f of x is a fixed element of size, say, 1000. Yeah, like so. There are how many elements in this f of y? F of x, 2 to the power of 1000. Yeah. What's the how many elements in the x? Potentially infinite. So many elements, right? So you can x going to f of x like. That kind of that's a kind of thing. So finding some x, f of x, yeah, x going to f of x, yeah, this is easy. But given element, so this is for example here. I mean just for this for example, lot of x here. When you multiply, you go here f of x. Okay, but you can see you're starting from this value, you go there f of x. There's another value, go here like that. But let's say if this is not given to you, from here you can't go back and find out this one. That's the kind of a one-way function. Okay, one-way function is the one where computing this is easy, coming back this is hard. Okay, that's the idea. Sorry. Yeah. So now. Here you see some of the things. Alice can create x in the domain. So the domain is the domain of a value, and x is in the domain agreed in advance, and he can keep it secret. And now compute f of x and send it to Bob. Now Bob cannot find out x because it's a one-way function, and Bob can now create secret y in the domain, and he can also compute f of x. F of y and send it back to Alice. Now what Alice and Bob have got now, f of x and f of y, sorry, Alice has got x and f of y, and Bob has got y and f of x. Now both of them have f of x and f of y. If f is such that they can work out a common function of their secrets, which others who observed f of x and f of y cannot compute, then one can attempt to have a solution to this problem. Because the goal is that both Alice and Bob need to have some common secret, known only to them, not to others. Okay? So Diffie-Hellman in their 1975 paper gave one such concrete solution, and that's why this kind of things. That's why it's a very wonderful idea. It's just an idea. So they wrote paper based on the idea, pen and paper. Okay. Now let's see how they do. Now for that, before that I need to introduce some numbers now. That is where numbers are necessary. Okay. So you got a prime numbers. Everybody knows about prime numbers, I hope, nowadays. Yeah, prime number, one, because the number is said to be a prime number. A number by definition greater than 1 that has no positive divisors except 1 and itself. Now examples, what is the first prime number? It has to be 2. So 2 is the first only, and that's the only even prime number. Think about it, after 2 became prime number, no other number can be, no even number can be a prime number because already 3 is same, right? Now, of course, the next number is 3. 3 is also a prime number, okay? And basically 2 and 3 are twin primes, and they are the best twin primes. No other prime numbers are so near. 2 and 3, they are together, right? And that's the only twin prime possible. And then if you consider, what is the next prime number? 5, right? So now 3 and 5, there is divided, remained by only 1, number 4 in between. Now, 3 and 5 is one such prime number. Now 5 and 7 is another such prime number, right? Now a question was asked, actually, are there any such prime numbers like that? They're called twin primes, like 3 and 7, only separated by a even number in between. 2 and 3, they are twisted, leave it aside. Okay. The next thing that you can have, thing is like 3 and 5, 5 and 7, 11 and 13, right? Now, how many are there? Are there plenty of examples? So there was a mathematician said, okay, oh, such twin primes must be plenty. There are infinitely many twin primes. Do you have a proof? Nobody had a proof. So you can actually find out, but even now, it is still a conjecture, but after so much of time, another Chinese professor from the United States gave a proof, saying that now he only he showed that there exist infinitely numbers whose differences can be bounded. That proof, and that became quite famous the world over. Okay? So twin prime is still, I think people still believe. So for example, if you go and look for the primes on the number line, there may be 2 prime numbers, 1 prime plus 2 another prime. Those 2 are prime numbers. And like that, you will see infinite prime numbers. Like, these are some fun facts about prime numbers. There are lots of fun problems about numbers, okay? And that's not our main idea, but we want to understand the numbers itself. And the next one idea, what we call, so after, the prime numbers, those numbers that are not primes are composite numbers, because they have to be composed by 2 other numbers, So for example, 4 is a composite number because the number is formed by 2 prime numbers, 2 times 2. Right? Similarly, 6 is another number, 3 times 2, like that. Okay? Composite numbers definitions are also clear. So for any integer n greater than 1, so now what we do, once we have a greater than n, I can now have a set 0, 1 up to n minus 1. So any number in n, and then all the numbers up to that point n minus 1 is a set of numbers. Okay? And this set is also called as residues modulo n. For example, the clock, how many hours we have in a day? 24, but we have AM and PM, right? So we start number like 1 o'clock, 2 o'clock, 3. After 14, you can come back to 1 o'clock again. So think about in the first time when you were a kid, your parents told you how to read the time from the clock. 3 hours and 14. You would have gone through some. Can you remember the first time when you found how to read the? Yeah. Think about it. Very interesting. The time wise, Initially, so that is clock arithmetic also follows the same thing. So we have a residues modulo 12, right? Anything you can do. So for example, 12, if it is 1, past 1, you get 1 o'clock. Then if you go past 2 hours, then you get minus 1, minus 2. You get 11, right? 11 hours. 11 minus 1 is same as 11. Okay. So we define the operations in set n using modulo operation. So that's what we're going to learn in today's this week's workshop. So what we do is we have a set with n minus 1, and then when we have a modulo operation, what we do, we add the number, we get an integer greater than n, but what we do, we divide by n and only keep the remainder. And we define that function as modulo n. And similarly, multiplication, you take x times y, you multiply these two numbers, say for example modulo 5, I get 3 times 4 is 12 modulo 5. So 3 times 4 is 12, but modulo 5 is 2, because I divide 12 by 5, the remainder happens to be 2. So similarly here, 6 plus 7 modulo 12 is 1, because 6 plus 7 is 13. So for example, 6 here and 7, 1, 2, 3, 4, 5, 6, 7. See, you got 1. So that's what you get. So modulo 7, modulo n is like working like a clock arithmetic. So if you have 6 o'clock and add 7 hours, you get 1 o'clock again. It's 13, but you can take modulo n, right? So and similarly for the multiplication is that. So in this lecture, n will only be a prime number. Okay. So such a prime number, you can assume. Clear? Any questions? Okay. Now I have a idea of an inverse I define. So when you have a modulo inverse here, let x belong to n if there exists an integer y such that x per y equal to 1. So here the definition of an inverse is mentioned here. Given an element in the set, if there exists an integer y such that x times y modulo n equal to 1, then we say y is the multiplicative inverse of x and is denoted by x inverse. So for example, we have 5. 2 is the inverse of 3 modulo 5, because 2 times 3 is 6, modulo 5 is 1. So hence 2 is the inverse of 3 and so forth. We can define the cyclic group over non-zero elements of Zp. So you can start with Zp star, which is all non-zero elements of a modulo p, leaving out 0, and take some element g in this set. They are such that g squared, g cubed, up to g power p minus 1, that becomes 1, and it will actually give you all possible these elements. Yeah, you can always find such elements. I'll bet you. So this one we don't. I cover this idea here. It requires more study, but you can see the textbook or other things you can see. Once you have such a group, which is a cyclic group, so using G you can generate all the elements in Zp. That is, and you can find the inverse. So here we have an example. So for example, you see here I start with 1, multiply by G to be 2. 2 is a generator. Now 2 times 2 is how much? 4, correct? Now 4 times 2, 8. 8 times 2, 16. But in this case it's modulo 11. So 16 modulo 11 is how much? 5. 5 times 2, how much it will be? 10. 10. 10 times 2, 20 modulo 11 is 9. 9 times 2 is 18, modulo 11 is 7. 7 times 2 is 14. Modulo 11 is 3. 3 times 2 is 6. 6 times 2 is 12. Modulo 11 is 1. So you can see that you have a cyclic group starting from 1, 2, 4 like that. Okay. Now you have a generator here. Power of 2 is here. Power of 2 modulo n here. And you can see, and the power of, given for example 8, which power of 2 gives you 8 is 3, and that is called the discrete logarithm of this number. So we have a discrete logarithm as given also in this one. So this is the example of cyclic group, generator of G. Order of this group is 10, and so really the discrete logarithm answers this question: what power of 2 is 3 in this case? Yeah. What power of 2 is 3, and from the thing you can write it as 8. But in general, given such a big number, answering this question is quite hard, and that's a one-way function. Is that clear? This is one concrete example of one-way function that Diffie-Hellman used in his paper. Now looking back to the thing, there are also some other things. Example of one-way function. you can see that you have 2 power x modulo m. So if you come through 1, 2, 4, 10 is also sometimes considered as -1, for just for your ease of calculation. So that this gives you an example of that. So the discrete logarithm problem is formally defined as follows. So given a generator G and H are the two elements in a group, then the discrete logarithm problem is problem of finding x such that G power x equal to H. This problem is a discrete logarithm problem. It's hard. For example, 3 power x is given 13 modulo 17. X is 4 because 3 power 4 is 81 modulo 17 is 13. So that's an example of that. So discrete problem is believed to be hard, and therefore it has become a basis of several crypto systems like Algol and others. So we define now a protocol. So here Diffie-Hellman protocol is described as follows here. Now Alice has both Alice and Bob has a generator. Yeah, they can and also know the order of the group. So Alice will choose some random number, in this case NA equal to 2, and she will compute G power NA. Okay, generator power NA, generator is 2, and the random number she has chosen is 2, and 2 to the power of 2 is 4, and she will send G power NA to the Bob. Now when the Bob receives G power NA, he cannot know G NA because it's a discrete logarithm problem, is hard. So what he chooses his own NB 6. G power NB is 2 power 6 is 9, and he will send back to the Alice. Now Alice has now G power NB, but she has NA, so she takes whatever that is sent by Bob, that is MB to the power of NA. So 9 square is how much? 9 square is how much? 81 modulo 11 is 4. Okay, and the Bob can choose MA, which is G power NA, which is 4 to the power of 6. 4 to the power of 6 is how much? Yeah, and it's the same number. Then modulo 11 gives you 4. So they can get a common secret, but kind of thing. So just to, in an abstract sense, I'll give you idea. I'll explain here. See, now the group is public. Okay, group is public. G, the generator, is public. Okay, and the P is prime. The P is a prime, which is public, right? Yeah, I know that. Now Alice, what she will do? She chooses NA, a random, belongs to ZP star. Okay, and she'll compute G power NA, compute, and send it to G power NA. Now Bob will choose NB, ZP star, random. You can put random here. Randomly choose a ZP star, and he will compute G power NB, and he will send it to here. Now see, now common K, what she takes, G power NB. Now Alice cannot know NB, but she knows G power NB, but she has NA. She will compute modulo P, and she has NB. He has NA, which is sent by Alice, but Bob cannot know NA, but he will compute NB, and he will put KBA. Okay. Now what is this? This is G to the power of NA, NB times NA mod P, and this one is G power NA times NB mod P. You can identify that both of them are same, right? So hence KAB equal to KBA. So they obtain common secret. Now only known to, so you see this is all happened in the Alice, this is all happened this. So G power NA goes here, G power NB goes there, but both of them has KAB, KAB. KAB, common secret are here. So both of them obtain an end common secret. Both of them obtain common secret, but what they exchange is G power NA and G power NB, which are public. So from G power NA and G power NB, nobody can get NA and NB. Hence, they would, you see, two users now who sent only public information, but they obtain a common secret. This is the idea of a Diffie-Hellman. Do you see? So if you can actually explain this to your friend with all the group definitions and everything, make sure that you understand this protocol. Through a pen and paper, you should be able to explain to the others. Is that clear? See, now think about from an adversary. Eve is here. She's seeing G power NA is going from Alice to Bob. G power NB is going to do. Can she do something? Does she have an algorithm, let us say an algorithm that takes G power NA, G power NB, and that gives rise to G power NA times NB? Does there exist an algorithm that takes this G power NA and G power NB as input and gives it to G power NA and NB? If somebody finds this algorithm, you will become very famous, because this is known as computational Diffie-Hellman problem. Look at the right of, it's a problem that Diffie-Hellman people said, okay, if somebody can really do it, then you can be, that's a hard problem. He didn't tell you actually it's a hard problem or not, because that problem is still open. If you want to prove that CDH is a hard problem, you still will become a very important person in a mathematical world. Everybody would follow. Yeah, but it's not there. But, classical computing, that's okay. With the quantum computing, you have a solution, but CDH is a problem. But see, what is the nature of this problem compared to discrete logarithm problem? So if somebody solves the discrete logarithm problem, let's say this is the challenge that we have. Algorithm, you want to find out algorithm of this one. This is called CDH. Maybe call it CDH of this, right? CDH of this is that. Now, I don't know how to do CDH, but let us say somebody claims that I know discrete logarithm problem. Okay, come on, if you know discrete logarithm problem, let us solve this problem. Because he knows G power NA, you apply discrete logarithm problem, you get NA. Once you get NA, you can choose one secret. So if you solve discrete logarithm problem, you can solve CDH. Okay? But
what university? The University of Melbourne.
Logarithm problem is hard. But conversely, if you solve CDH problem, can you solve discrete logarithm problem? Even that is not clear. Okay? So at the moment, CDH problem is hard, discrete logarithm problem is hard, and the interrelationship things are also very interesting. So this is the complete definition of a, this is a Diffie-Hellman problem. You can see that I have written in the left-hand side is the domain in which the discrete CDH problem works, or the Diffie-Hellman protocol works. It's arithmetic modulo 11 in this case. Alice chooses NA and senses G power NA, and Bob sends G power NB. They obtain common key as G power NA times NB, and these are the two guys to do. And I have actually given the definition of the one which I mean the CDH problem is problem for the Eve in this protocol is a CDH problem. So really when they wrote a problem, they also actually give another problem. So cryptography, getting a paper is easy. We can always write a problem and give another problem and write another paper about it. So what these two gentlemen did was basically, they didn't solve the real problem, but they solved in one sense, but by giving another problem. That is the CDH problem. So you can see that these problems, this is a very interesting one, and you might go. So you can read the paper and get this. Clearly, solution to discrete logarithm implies solution CDH. Is the converse true? That's still an open problem. So, so here, issues with protocol. Is it secure? So this protocol, exchange data is only G power NA and NB, and Alice cannot guess NB, and Bob cannot guess NA. So their secrets are safe from each other, but also none can guess NA and NB for the same reason. Both Alice and Bob can compute common secret. It is believed that G power NA and B can be computed, cannot be computed by others who can only see G power NA and NB. So this is also later is a hard problem. But what you can do with this one, with this kind of problem, it is not safe because there is something called man-in-the-middle attack. If Alice and Bob are working through a problem, and actually a man in the middle can come in between, and let's say Eve, and he can convince Alice that he is Bob and obtain a common secret. And similarly with Bob, he can obtain a common secret, and then onwards, whatever the communication that he is getting from Alice, he can actually decrypt and send it whatever way he want modify it and send it to Bob, and Bob and Alice wouldn't notice. So this is called a man in the middle attack. Is that clear? So this is possible because when Bob receives a communication from Alice, there is no way for him to determine it's indeed coming from Alice, because what he gets was some big random number, and that anybody could have said. So the idea is that this protocol is really a good protocol, but it doesn't have authentication, and for that we need another type of cryptography to do that. So in practice, we use basically SSL protocol, which uses similar to whatever this Diffie-Hellman, but with some signatures. Okay, using what's called signature, which we will develop in our course. So the basic security objectives are there. So I'm actually run out of my time. I don't want to continue this part, and tomorrow we'll come back with. I will start with also basic numbers and how to study. What are the things you required? So if you are confused about the numbers or what level of mathematics you need for this course or everything, don't worry too much on it. We will help you with the workshops, questions, and everything. And there are also other, nowadays on web, you will get lots of tutorials which help you to explain these concepts in a much better way. So depending on your background, you can go through and study. I can suggest some further readings. See you tomorrow. Tomorrow in the other building, yeah.
Okay. Two is inverse of 3 in Z5. Or in other words, 2 is inverse of 3 modulo 5. Okay, we can now define a cyclic group over non-zero elements of ZP where P is prime. That equal 5. Hello Navneet. Sign up is not working? What sign up is not working? Are you talking about the app? Ah, right. Yes. Let's have a look. Oh yeah. Yeah, the sign up doesn't work here right now because there hasn't been functionality for that. But you can just log in with demo@example.com and then demo as the password. If you just want to have a look, you'll see my own avatar here. But that's because that's hard coded. But yeah, it's still in the process of being built. Will you publish on Play Store? If you're talking about Android, will I publish to Android? That might be way more further down the line, because right now all I'm focused on is the web version. But yeah, it will be way down the line that I implement some, iOS and Android equivalents at some point in the future. Prasad Ware says, how can we use Obsidian Effective? What all things do you use it for? Alright, I'm guessing what things do you use it for? Well, right now I'm writing my notes for it. I got a few ideas as well that I just write in as well. Sometimes, it's just Leetcode questions that I want to keep a copy of my own ideas about. I would just write a new note. I use the create a new note functionality in Obsidian to just create one with a specific ID in the title each time. So if I click create a new note, it'll create one with the timestamp. But otherwise I use it for just like note taking and sometimes for like journaling as well. Give link of your keyboard. If you search up Glove 80, I put it in the description, but if you search up Glove 80 you'll be able to find it. Otherwise I can just put it here actually. Go to MoErgo. Page 25, 26, 27 maybe. See. 26. We're fine with that, I think. understand, so discrete logarithm. X is 0 to 11. To the power of 1 is simple cyclic group modular. Oh, Navneet, can you break Enigma with cryptography? I can't. Not yet. Maybe. And hello to you too, KFC. Order size of G, generator 2. 2 is the generator. If 2 is the generator, mod P Thanks for the follow, Stephen. Let G and H be elements of the group G, then the discrete logarithm problem is the problem of finding x such that gx is equal to h. For example, the solution to x in the problem 3x equals 13 mod 17 is x equals to 4. The discrete logarithm problem is believed to be hard, therefore it has become the basis of the several public key schemes, for example LGAML. Next we will consider the Diffie-Hellman protocol, the first public key algorithm. The protocol is defined over a cyclic group. Okay. G equals to 1. Kind of understand that. A cyclic group. What is a cyclic group? Maybe on page 30, probably. 29 maybe. Good 29. Yep, okay. Ooh, Control Shift T. What is a cyclic group? Is that right? Navneet says, which hair oil you use? My own natural oils. Honestly. In the sense that, I probably only wash my hair. I wash my hair, I drench it in water, but then I don't always use conditioner or shampoo, but I wash it. That way it doesn't damage the hair too much. Basic security objectives. Let's see. Before I continue, Yeah, finish lecture slide reading. That includes this section and sections on GCD. Yeah, not bad. Alright, I'll do that. So basic security objectives. Talking about this now. Three important concepts of information security: confidentiality, integrity, and availability. So this might be useful here actually. .36 or 35, I'm gonna say. Let's see if it goes to 35. Yeah, it goes to 36. Okay. In simple terms, confidentiality of information or data ensures that the access is given only to the authorized individuals. Information integrity ensures that enough safeguarding mechanisms exist so that authorized individuals get the right information, and changes to the information by intentional and unintentional means will be detected. Okay. Availability, information or data availability ensures that the information is authorized. That the information is authorized available to the users. Sure. OSI security architecture. How to define the requirements for security in networked world and categorizing the approaches to satisfying those requirements. Refer to the ITU-T X.100 800 security architecture for OSI. It defines a systematic way of defining and providing security requirements. Three main aspects. Let's see. Security attacks. Security mechanisms, security services. Security attack. Attack is any action that compromises the security of information owned by the organization. Threat is a possible potential for violation of security. Information security is about how to prevent attacks, or failing that, to detect attacks on information-based systems. Right. Often threat and attack used to mean same thing. Threat is attack in waiting. Generally, we have a wide range of attacks. Some general type of attacks is passive and active attacks. We concentrate on implementation and mechanisms aspects of information security. Implementation and mechanism. Okay. Authentication, confidentiality, integrity, non-repudiation, and availability. Okay. Security threats in the networked world. Security services are defined to address or withstand threats. Interception. Modification, integrity, fabrication, confidentiality, authentication. Okay, so security services are defined with those. Yep, security threats in networked world. We can non-repudiation, source authentication, and interruption. Network QoS, quality of service, maybe. Model of network security. Can't see that very well. Let's see. Adapt to theme. So, okay, here we go. Model of network security. Message sender, security related transformation. Secret information. Secure message. Information channel, secure message, security related transformation. Message. Trusted third party arbiter. Distributor of secret information. Model of network security, yeah, fair enough. That's pretty straightforward, to be honest. Network security model. Oh, well, that's also in black and white. Okay, let's have a look. Network access security model. Opponent, human, hacker, software, virus, worm, access channel, gatekeeper function, information system, computing resource, data process, software, internal security controls, network access security model. Alright, sure. I think that's pretty good as is. And we can finish this off. Fundamentals, set source, finite sets and functions, basic facts, division and remainders, prime numbers, GCD computation, Euclid's algorithm. Euclid's algorithm is something that I do got to remember, which I think uses GCD computation. Just got to figure it out. So greatest common divisor computation. Right, let's see, basic numbers week 1. I am gonna have to start from greatest common divisor. Maybe GCDBR. What I need. I remembered something. We good? Think. Alright, it's time to have some lunch. Be right back.
妈妈怎么了？啊好。哎呀，我小弟都等不及了。在哪里？哦，我小儿还好，小弟，已经老了，腰都直不起来。
哎，你腰直不起来，你这该锻炼了。你这锻炼，我比你还老，我怎么的？
是吧？
Sayantan Talukdar. Sayantan Talukdar. Hello. So you ask, hi David, hope you're doing well. Could you list 3 things you'd do differently? Give advice to someone who is starting out. If you were to restart your streaming journey. Well, good question. Do I have a good solution? Alright. I would say there might be... Let's see what I can list, alright? I think, in terms of streaming, 1, find something that you're interested in. To me, this was the things listed in my title: Leetcode, the Odin Project, the scheduler development that I'm doing, and I got a little bit of a flair in the sense I got this keyboard. There's a little bit of a difference to what I'm doing every day than what the average person might be doing. Like that's one thing. Just have your own quirks, Number 2, I would say, is to not be worried about what others think of you. Right, this goes along with the having quirks thing. But I would say you could extremely limit yourself by thinking that what you can give is not good enough. So that's something I personally felt in the past that now I don't feel so much. Just within like the last 2 or 3 weeks of streaming. And I've had this channel for a while now, so the amount of subs I've had has grown steadily, but still steady enough for me to think that I'm not really, if I uploaded something, say if I uploaded a stream, that people would just unfollow me endlessly, right? I would imagine that people would have just unfollowed me endlessly, but it turns out that it's been the opposite, and I've gained 200 or so subscribers over the past month, let's say. So that definitely came as a shock to me. I think that's all I can say to that. But yeah, believe in yourself. Even if you think it looks stupid, it might not be for someone else. And I just came back from lunch and having a shower. And I forgot to turn on my cam. Hello. And I don't even know if Sayantan is here. But yeah, that's my thoughts anyway. Sayantan, this is for you. Okay. Now let me continue. With what I have to do. Maybe let's do a quick monkey type. Just because I want to get the fingers moving a little bit. No. That's all right. All right. It's not yet time. quiz. Okay. Can't get this working. That's fine. Refresh, not refreshable. Okay. Let's close this. Close that. Let's reopen it. Looking at openings, yes. It's fine. That's fine. That's very weird. There we go. Don't know what that was. Quizzes. Okay, resume quiz. True. Data origin authentication does not provide protection against the modification of data units. Data origin authentication. Confidentially. True, I suppose. Data origin. Authentication. Message authentication. Yeah, no, I don't know. I'm going to say true. The emphasis in dealing with active attacks is on prevention rather than detection. It's a good question. I doubt. So prevention. Okay, prevent attacks. Sure. A common technique for masking contents of messages or other information traffic so that opponents cannot extract the information from the message. Masquerade. Encrypt. Integrity analysis. Encrypt. should be encryption. So something involves the passive capture of a data unit and its subsequent retransmission to produce an unauthorized effect. Service denial, replay, disruption, masquerade. I feel like it's masquerade. I'm just gonna guess. And then the three concepts that form what is often referred to as CIA are confidentiality, integrity, and availability. A loss of something is the unauthorized disclosure of information. Integrity or confidentiality. I think it's confidentiality. Let me just recheck. So confidentiality would make sense for integrity is whether the authenticated user can probably access something. Probably. Let's see, so integrity. Information integrity ensures enough safeguarding and mechanisms exist so that authorized individuals get the right information, and any changes to the information by intentional and unintentional means will be detected. Confidentiality, in simple terms, confidentiality of information of data ensures that the access is given to only authorized individuals. Verifying that users are who they are and that each input arriving at the system came from a trusted source is authenticity. Authenticity. Credit none. Might be integrity. A something takes place when one entity pretends to be a different entity. Wait, how many attempts do I have at this? Unlimited, time limit none. A something takes place when one entity pretends to be a different entity. Masquerade, I suppose. Replay is the protection of transmitted data from passive attacks. Non-repudiation. I'm going to have a look at what non-repudiation is. Source authentication. Got to look at passive, some generic types of attacks, passive aggressive. Let's see. Oh. So you don't know the answer. G10. Udochan. I have some questions for the first lecture. Wait. Comp 90043. Cryptography security, okay. The attendance of tutorials, can I attend some different tutorials on different weeks? If possible for me to publish the research project somewhere in a publication. Where will kind of rooms? Yeah, these are good questions. I'm gonna keep an eye on this one. Sabel Wang Wills. Hi, Udea. Thanks for the lecture. I was watching via live stream and found that it became very difficult to hear as you move away from the fixed mic when text. Click on mic or try to stay close to the desk. It would be great. Yes, I agree with that. Error in slides. No, it's not error, just the definition. This year workshop starts in week 1. We're good. That's fine. So, attempted week 1 quiz done. Temp week 1 workshop for 30 minutes. I'm gonna do that a bit then. Only problem is, how can I guarantee? Who is this, by the way? It's not Udea, is it? He's so much younger. Okay, I'm going to start on some of those questions and then make note that I could read a little bit on new directions in cryptography. Read that. Diffie-Hellman. It's pretty good actually. I see. I could read some of this, Okay. That's fine. I can save this, which I have. Downloads 24. This is technically going to be called resources. PV helmet paper. No, I can't automate that, can I? Nah, don't worry about it. Okay, so it's done. New directions in cryptography. That's there, optional, and now I can attempt the file. Just gonna time myself 30 minutes. Okay. Let's have a look. Should I send that to myself? Maybe. Maybe. Shall I? use z, z plus, z minus, n plus to represent the following sets. Z minus. Z. Sorry, n plus, and z. No problems. What values do the following sets represent? Please list all values. So, from what I understand, okay. Question 2. Z7 from what I remember, it's the set of 1, 2, 3, 4, 5, 6, 7, not including 7, I believe. You know, C Z of n, I'm just thinking like it's got to be 1 dot 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 n minus 1. That's what I'm thinking. That's not gonna be in this one, it'll be in this one. So this one's still all bright, doesn't matter. No, never mind, it starts from 0. So it has to start from 0. 1, 2, 3, 4, 5, 6. Prime numbers. What is a prime number? Identify prime numbers in Z21. Prime number. The formal definition of a prime number. I have to write this down. But a prime number... Yeah, man, I gotta write the definition down probably. Prime numbers. A number is said to be a prime number if p is greater than 1 and p has no positive divisors except 1 and p. Positive divisors except 1 and p. Sure. Prime number. A number p such that there are no other positive divisors other than one and p. Number is said to be a prime number. The number p such that there are no other positive divisors except 1 and p. Except 1 and p. A number p greater than 1 such that there are no other positive divisors except 1 and p. And with that, we also have to say, so identify the prime numbers in Z21, 2, 3, 5, 7, 10, 11, 13, 17, 19, 20, 21. Sure. A function triplet is defined as follows. ED 0 or 1 F, where F maps from E to D. What are the size of the domains and codomains of function f? 2 to the e for the domain, range or codomain is 2 to the d. Question 5. Modulo arithmetic. Solve the following pairs of numbers using modulo arithmetic. Yeah, I'm gonna need practice on these. 73 mod 23. What is the modulo arithmetic? Greatest common divisor. Euclid's algorithm, modular arithmetic. Yeah. Let's say A and B. Let A and B be integers. And let n be a positive integer. We say A is congruent to B, modulo n, and write if A and B differ by a multiple of n, i.e. if n is a factor of b minus a, every integer is congruent mod n to exactly one of the integers in the set. We can define the following operations. When the context is clear, we use the above special addition and multiplication symbols interchangeably with their counterpart regular symbols. Does this make sense to me? You know, there's an abstraction on abstraction that's keeping me from understanding this well. Extra. Two integers, p and q, are said to be congruent modulo n if p mod n and q mod n Right. This is written as P equivalent to Q mod N. What are the above questions? What are the above questions congruent to? Okay, greatest common divisor is defined as the largest number m which gives two numbers p and q, which divides two numbers p and q. Find the greatest common divisor in the following pairs of numbers using the Euclid's algorithm. Make sure that you understand the process. You should be able to carry out the computation on a new set of numbers. Try creating your examples. Sure. Write the pseudocode for GCD algorithm, if possible implement it using a programming language that you are familiar with. Study modulo inverse by yourself. Please read chapter 1 of the textbook. What textbook? What textbook? Whatever. 73 mod 23. I think I know how as easy it is, right? So 73 mod 23 is just what, 46, 69, 4. Negative 11 mod 7, 7, 14. You go negative, so 0. So what do I think? Plus 7, negative 4. It's negative 4, but you can have negative 4, I guess, or 3. You can have negative 13 squared mod 9. Am I missing anything? Right, so D divides two integers m and n as a common divisor. Two and four is 2. Then GCD A, GCD B are... Doesn't matter, I think you still have to think of it in terms of what 169 div 9 is 1, 9, 7, 9. 70 is gotta be 79, 79. If you got 81, you got less than 81 is going to be 8, so 72. 72 is going to give you a leftover of 7. So you're going to have a 7 as a leftover remainder. Sure, right. 32 mod 19 is going to be 20, you're going to have 13. E negative 2, 3. So you're going to have negative 8 mod 17. So you negative 8 plus 17. It means it's a 9. Negative 1 mod 19. Isn't it just 18? And two integers P and Q are said to be congruent if this is written as, what are the above questions congruent to? I guess for the above questions, each of them are congruent to '73 plus 23n. I would assume something like this, right? More generally, if A mod B, then A plus Bn, where n, so that's only the number. Mod 23. Something like that, right? A plus Bn. Don't tell me that's what we end up doing. A useful theorem? Maybe that is. Maybe that is. Let me read this. So if A and B are identically 0, then the remainder is 0 and the result is trivially true. Let's see, so let A, B and R be such that, so if A and B are 0, then R is 0, then GCD of 0, 0, greatest common divisor, is going to equal to the greatest common divisor of 0 and 0, which is 0. So it's just 0. Otherwise, let D be the greatest common divisor between A and B. Since D divides A and D divides B, we have D divides A minus QB. Where Q is an integer. D divides A minus QB because A minus QB is R. The divisibility property for, is that not like the linear combination property? Linear combination property. So D div R and D is a common divisor of both B and R. So D div R and D is a common divisor of both B and R. Now let C be a divisor of B and R, i.e. C div B and C div R. Then again, from the divisibility property, C div divides QB plus R. So by that property again, you apply that property again. Because you can give any Q, any IC. Is that just, you just give any, right? You can just give any. So since DA we have this, using the divisibility property. So DR and D is a common divisor of both B and R. How do you get that conclusion? D and R, D div R, and D is a common divisor of both B and R. So D and R, and D is a common divisor of both B and R. Now let C be the divisor of B and R. So C div B and C div R. Now let C be a divisor of B and R. You're just letting, right? Then again, we can use the divisibility property to say that C divides QB plus R, so C divides A. So because that's A, right? Yeah. KFC says, hey bro, what are you working on? I'm working on understanding the theorem for GCD, greatest common divisor. This is all about modulos. So I'm working on cryptography and security. But understanding this concept will help me understand better the Diffie-Hellman key exchange protocol. Because I'm pretty sure that's probably going to be a big part of this subject. So understanding GCD, understanding modulos will probably help me in this respect. And I've kind of gone through this already in the past in another subject called group theory and linear algebra. But this this subject just touches that subject on the edges. It's pretty good actually. But yeah, anyway, so trying to understand this again. Then again, from the divisibility property, C divides A. This means that C is a common divisor of A and B. So C is less than equal to D. This implies that D is equal to GCD of BR. Thus we have proved GCD AB is equal to GCD BR. But the key point is C is less than equal to D. How do you understand that part? You know. So this means that C is a common divisor of A and B. C is a common divisor of A and B. Sure. So what does that even mean though? If A and B are identically 0, then R is trivially true. Otherwise, let D equal to GCD AB. And that's the greatest common divisor. Now let C be a divisor of B and R. C divides B and C divides R. Then again, the divisibility property. This means that C is a common divisor of A and D, A and B. So C is less than or equal to D. This implies that D is equal to GCD of B and R. Thus we have proven GCD AB equals GCD BR. Yeah, the part that confuses me is now let C be a divisor of B and R. Okay? That's what confuses me. I'm gonna have to like read up on proofs. It's probably going to be helpful. It's probably going to be helpful. Yeah, and how do we conclude C is less than or equal to D? In the first step, it's proven that D is the divisor of B and R. In the second step, it is proven that any common divisor of B and R is less than or equal to D. Since the common divisor is less than or equal to D, and D is a common divisor, it must be the greatest common divisor. It is true in the first step that D is a divisor of B, R, and A, but A is not important because of the goal is to conclude that D is a divisor of both B and R. So while it's true that also a divisor of A, that information is omitted in the last sentence because that's not the goal. We conclude that C is less than D because D is the greatest common divisor of A and B. Since C is also a common divisor of A and B, it has to be the most of the greatest common divisor. That's what greatest means. It means all the other ones are smaller or equal. I will need to understand further with another question. I'm gonna have to watch this video. Just gonna pause the music for a second.
Hello and welcome everybody. Thank you for visiting my channel, Just a Guy Who Likes Math. Today I'm going to prove the proposition. Let A, Q, B, and R belonging to integers such that A equals QB plus R. Then the greatest common divisor of A and B equals the greatest common divisor of B and R. Now this, you obviously know that this is like the quotient to remainder kind of equation. So yes, we have to prove this. We could actually, before we start off, assume A times B does not equal 0, which actually means A does not equal 0, and B does not equal 0. Because if this is the case, then this whole thing becomes a moot point. It's fair to assume this. By the way, this actually is very important in the Euclidean algorithm. But yeah, let's get started. So let's say we do have an integer, D, which is the greatest common divisor of A and B, which means D divides A and D divides B. That's correct, right? So yes, if this is the case, then D has to divide any linear combination of A comma B. Now this is the truth. This actually just means I'm going to write down up here, D divides any x A plus y B. I'm just going to take an example real quick. Let's say 5 is the GCD of 25 and 30, right? So 5 has to divide any linear combination. Let's say 2 times 25 is 50. 2 times, let's say 3 times 30 equals 90. So 5 divides 140, which is, true. So yes, so D divides any linear combination. Now let's say the linear combination is actually A, so it's 1 x's, x in this case is 1, and minus QB. And y in this case is negative q, or minus q. We chose this number specifically because this actually equals r, right? Because if the qb comes on this side, r equals a minus qb, which is actually right here. So we know D divides r. But this just proves that D is a common multiple. I'm sorry, a common divisor of r. We don't know if it's, yeah, we just know that. So
It's a common divisor.
D divides r, and then we know D divides b. So this just means there exists D that divides r and b, but we don't know that. We still don't know that D is the greatest common divisor of B and R. But yeah, this is a start. What we do next is this. I'm going to show that D is the GCD of B and R. It actually suffices, I'm just going to write it down. It suffices to take another common divisor of B and R, let's say C. So C divides B and C divides R. And we must prove C is less than equal, less than or equal to D, right? So we have C divides B and C divides R. So again, C divides any linear combination.
Yeah, but why can you say... Yeah, that was written.
B and R. So in this case, we'll take C divides QB plus R. In this case, x equals q, y equals 1, as from the previous page. So yeah, and this actually, we took this for a specific reason, because this equals a, right? Because a equals q plus r. So we have c divides a and c divides b. So c is a common divisor, of a and b. in the beginning, we actually had taken D is the greatest common divisor of A and B, right? So we already know, so C divides A and B. D is the greatest common divisor of A and B. So C has to be less than or equal to D.
Okay.
Which is actually what we set out to do. Prove that C is less than or equal to D. Therefore, we have that D has to be, whoops, I'm not showing you. So D has to be the GCD of B and R. This makes sense. This is actually going to be the Euclidean algorithm, which I'm going to show next time.
Yeah, okay.
And yeah, if you do have any questions, feel free to leave it in the comment section below. A like and subscribe is always appreciated. But yeah, until next time, peace out. According to
Suffices to take C div B and C div R. Okay. So this means that C is a common divisor of A and B. Yep. And D we said was the greatest common divisor. So C is less than or equal to D. And since C is less than or equal to D, this implies D is the greatest common divisor of B and R. Let's go back here.
done this, and then we know D divides B. So this just means there exists D that divides R and B, but we don't know that. We still don't know that D is the greatest common divisor of B and R. But yeah, this is a start. What we do next is this. We must show that D is the GCD of B and R. It actually suffices, I'm just going to write it down. It suffices to take another common divisor of B and R, let's say C. So C divides B and C divides R. And we must prove C is less than equal. Less than or equal to D. Right? So we have C divides B and C divides R. So again, C divides B.
So then why does proving that tell you that D is going to be equal to GCD B R? You know?
D of B and R. It actually suffices, I'm just going to write it down. It suffices to take another common divisor of B and R, let's say C. So C divides B and C divides R. And we must prove C is less than or equal.
Strategy to proof is to first create two sets, one set of the common divisors of A and B and the other set of the common divisors B and R. We choose an arbitrary element one set and use the corollary to show it is contained in the other. We'll do this operation for both sets to demonstrate double containment, implying sets are equal. Once we've concluded the two sets are equal, we can just say the larger value in the set is the greatest common divisor. I'll write that down though. I have to read this properly. Things you should already know before you can complete proving two sets are equal. Definition of divides. Jumping in and immediately trying to prove something we may not fully understand is a recipe for frustration. Let's take a look at some examples to fuel our intuition. The lemma states that we have a number A in the form of BQ plus R. Then the GCD of AB. Oh, it's 1 minute before I go to the gym. Give me a second. Alright, so we'll come back to this problem, okay? We will give it a break for now. KFC, hello. Says you went to the gym? Yep. I also went to dinner actually. So I also ate some stuff. But now I'm back. And I'm just writing my own manifesto right now. Because I just had a thought about it. Just a little bit. You know, what does it mean to be principled? Because I say in my own title, like on my profile, I say my journey as a forever learning principled programmer. You know, what does it mean to be principled? What do you mean by principled? I want to follow the best practices for any particular problem so that it makes development easier for anyone that picks up my code. I'll abide by this policy through reading any necessary documentation to understand to a deeper level of everything that I write. It's trivial to use LLMs, but it's next level when it comes from the heart. I don't know, that's a bit cringe. What is the time there? 7:45. 7:45. But yeah, definitely night out. I don't know, still a little cringe to write it like that, I suppose. It is trivial to use LLMs. The code is trivial to use LLMs. It doesn't make sense. How did you learn DSA? Basically from the 3 years of study, basically, I would say. What can I say? I mean, you know, I would say a good resource would be Neetcode to learn DSA. You know, I think learning any of these are pretty much all you need to learn all about DSA in terms of algorithms. But yeah, I took a few courses at uni that actually helped me solidify a lot of algorithm knowledge. You know, there was probably like 3 subjects: foundations of computing, foundations of algorithms, and an algorithms and data structures class specifically. So, you know, those were some of the classes I took. and where you talked about linked lists, binary search, some declarative programming, dynamic programming, same with 2D dynamic programming. Greedy search I learnt from a lot of AI specific courses. Heap and priority queue as well from a algorithms and data structures class. Graphs also from data structures class. Trees as well, just binary trees and all that stuff. Same algorithms and data structures class. Backtracking is more from AI classes that I've taken as well. But this shouldn't be hard to learn once you know trees as well, so it's not really that difficult. And then there's math and geometry all the way down at the bottom there, but I actually took some math courses as well, which also helps in some understanding. Bit manipulation, that's pretty much just taking C programming courses as well. I mean, Foundations of Algorithms was basically all written in C, so you have to go down to the byte anyway, so I've learned a lot there as well. So yeah, everything is, you learn a lot just by going to uni and doing some of the courses there. Otherwise, just follow the courses from Leetcode and you can probably equally do it as well. But yeah, just make sure you understand fundamentals when you're actually looking through them. And don't just memorize. Yeah. What do you mean by principal programmer? I want to follow the best practices for any problems so that it makes development easier for anyone that picks up my code. I will abide by this policy through reading any necessary documentation to understand to a deeper level of anything that I write. It's trivial to use LLMs, but it's next level when it comes from the heart. Yeah, I mean, that's pretty cool, I guess. Or shall I put that above? Oh. Control V. What if it goes like that? Yeah. Control Z. Sure. Doesn't matter really. How does it look now? Refresh. I am okay with that, to be honest. That doesn't look too bad at all. You know, what does it mean? What do you mean by principled programmer? I want to follow the best practices for any particular problem so that it makes development easier for anyone that picks up my code. I will abide by this policy through reading any necessary documentation to understand to a deeper level of anything that I write. It's trivial to use LLMs, but it's next level when it comes from the heart. Cringe, but well spoken, let's hope. Alright. Enough about that. That was just on my mind for a bit. But now I've done that, so I'm alright. Man. Okay, so here's the problem. I wanted to finish off just understanding this type of problem. And I can do the tutorial tomorrow and understand it even more, but at least for tonight I need to fully understand how this works, how this cryptography and security, greatest common divisor work, right? So this theorem is something I want to figure out and understand to its fullest, because like I said last time, how can I know that it suffices to find that C is greater than D, which implies that D is the greatest common divisor of B and R? I know C has to be less than or equal to D, that's fine. But how does it imply that D is the greatest common divisor of B and R? So let's try and see that through some of these examples. 26 is equal to 6, 4 plus 2. remainder is 2, B is 6, A is 26. Common divisor of 26 and 6, 1 and 2. Yep, and then common divisors of 6 and 2 is 1 and 2. GCD AB is 2, GCD BR is 2. Or another example, 60, 24 to 12. Ooh, hello Mehmet. Hello to you too. Utichi. Mehmet Utichi. I probably mispronounced that, my bad man. But hello to you too. Welcome. I'm just learning about GCD. It's been a lot of study today actually, I would say. No, you did great. Okay, so another example, so common divisor 60 and 12, 60 and 24. 1, 2, 3, 4, 6, 12. Common divisors 24 and 12. 1, 2, 3, 4, 6, 12. Yeah, I think I'm convinced. Okay. So 110, 30, 3, and 20. Common divisors 1, 2, 5, 10. 1, 2, 5, 10. And that's equal to 10. So it seems that not only A and B and R share the same greatest common divisors, they share all common divisors. If we can prove that the set of common divisors of AB and the set of common divisors of BR are the same, simply choosing the greatest value in the set will get us the GCD. Man, I gotta write this down. This is some like good intuition. What is the intuition behind GCD? I'm gonna just say GCD for now, right? GCD. Under it, intuition behind GCD. And I link that to the examples here. That's all right. Supporting theorems. Before we can prove the lemma, we need the help of a supporting theorem. If C divides A1 up to AK, then C divides A1U1 plus all the way up to AK UK for all integers U1 to UK. Yeah, so this is just the divisibility of linear yeah, you can divide linear combinations. The following corollary summarizes a theorem for the case of two numbers. Yeah, okay, corollary of a if C divides A and C divides B, then C divides A U plus B V for all U and V in an element of Z of the integers. Observe 3 divides 6 and 9. Then we can add 6U plus 9V. Alright, C divides A, or C divides, so 3 divides 6 and 9. and 3 will divide the result. Fair enough. Why is this useful? We need some way to relate the divisors of AB to the divisors of BR. The corollary gives us that relationship. Let's take a look at A equals QB plus R. We can rewrite this as A equals to B times Q plus R times 1. According to the corollary, if we know that D divides B and R, then we can conclude that D divides BQ plus R1, which is equal to A, thus D divides A. Yeah, that's fine. So the proof strategy. The strategy of the proof is to first create the two sets. One set with the common divisors of AB, the other set with the common divisors of BR. We'll choose an arbitrary element in one set and use the corollary to show it contains in the other. We'll do this operation for both sets to demonstrate both containment, implying the sets are equal. Once we've concluded the two sets are equal, we can just say that the largest value in the set is the greatest common divisor. Wow, so we basically... How does that even work when you say two sets are equal? That's crazy. So the proof. A is equal to BQ plus R. Let D equal to... D is an element of Z, but such that D divides A and D divides B. Alright, so it's all the set of elements where D is a common divisor of A and B. And let D prime be all the common divisors of B and R. Let X be an element of D so that X is a common divisor of A and B. Observe that A is equal to BQ plus R, which is also equal to A minus BQ, which equals to R, and that A1 plus B minus Q equals to R. By the corollary, X divides this whole thing, which is equal to R. Thus, X divides R. Since X divides B and X divides R, well then X is an element of D prime, which means it's a common divisor of B and R. So D is a subset or equal to D prime. Oh my god, that's big. I see, I kind of understand it more now. Let X be an element of D prime, so X divide B and X divide R. Okay, so X is basically... Yep, so we basically do the opposite, right? So observe that A is equal to this, which is also equal to that. By the corollary, X divides BQ plus R1, which is equal to A. Thus, X divides A. Since X divides B and A, X is an element of D. So D prime is a subset or equal to D. By double containment, we show that D equals D prime, meaning that common divisors of A and B and the common divisors of B and R are equal. The greatest common divisor A and B and greatest common divisor of B and R are thus identical and equal to the largest values of the set. Wow. Double containment, something that they just don't mention here. Man, that is unbelievably helpful. Okay, so here's the thing. I'm going to be bold and say prove that GCD of AB is equal to GCD of BR. Given ABQR are integers. Can I say that? Yo, why is this good? Whoops. Prove that. Okay. If A equals BQ plus R. And I'll use specific dollar symbols here so that can be good. And I'll probably use it here as well, to be honest. Yeah. Prove that GCDBR if that. Intuition, proof, and proof strategy, and tools utilized. Additionally, what what do I say? So, double containment. Double containment is another thing that I just want to read up on real quick. Containment. It's not. containment proofs. I can read these, but is it really worth it? Yeah, double containment. Set double containment. Well, proofs involving sets. I just want a good example. Maybe it is this. It is often necessary to prove that one set is contained in another. These are called containment proofs. This amounts to proving for all x is an element of A, x is an element of B. Is that for all? It is. That is, if x is in A, then x is in B. What do you think the first line and last lines of such proofs should be? Take A arbitrary, then x is in B. Recall we have defined the following operations so far. A or B is a set of elements such that are in A or in B. That is, all x is an element of A or B then x is an element of A or x is an element of B. Therefore, how do you think you use the information that x is an element of A or B? You can do cases of whether x is an element of A or x is an element of B. For all, so A and B is a set of all elements that are in both A and B, that is, A and B. How do you use this information? You know that x is an element A and x is an element B. For any set A and B, we have A and B is a subset that are or equal to A or B. Is that true? A and B is subset or equal to A or B. If A or B is yeah, A and B would be nothing. If it was combined, it would still be A or B would still be more than A and B, but it still includes us, so that's fine. Take arbitrary, so that in particular, for equality, remember A equals given A is a subset equal to B and B is a subset equal to A. Therefore, there are two directions, A to A equal B. One of them you must take an element of A and show it is in B, and the other when you take one in B and show that it's in A. We'll see more examples of this soon, but we'll need a few more ways to build sets. Alright, question 2. What would it take to show that not A is a subset, so A is a subset of B is not true? You'd have to show that show an X that is in A but is not in B. We'll see some examples later. Yeah, okay. That's not necessarily what I want, but double containment is kind of what I need. A strategy for proving sets are equal because they are subsets of one another. Double containment can be a good way to prove that two sets are equal to one another. Now, containment proof, does this have double containment inside it? Can't say double, can't find double. So I'm gonna just use this article as a way. I know this is not necessarily the best way, but it's a way. Control Z, Control Z, Control Z. Nope, that's not it. Double containment. Control V. Oh, good. Okay, and additionally, it should now be easier to understand the proof laid out in page 21. Basics, numbers, week 1. Gotta see if that actually goes to the page that I wanted to go. No, it's 20. Okay, that should work, doesn't matter. There we go. Okay, so that's good. I'm good with that. Now that I understood that better, I'll still need to reconsider. Oh my god. I need to open up those tabs back up. Because this one's a very good video just on the same concept.
Is the greatest GCU. It actually suffices.
Yeah. Okay. 303. This video. Share this actually. Start at 303, sure. Okay, epic. So that's good. I like linking my thinking. Now going back to the actual workshop week. That is written as P mod n, is that not just 73 is equal to some number times b with a remainder r. Alright, modulo is just that. Is equal to some remainder. Right. Some remainder. Okay, greatest common divisor is defined as the largest number m which divides two numbers p and q. Find the greatest common divisor for the following pairs of numbers using the Euclid algorithm. Make sure that you understand the process. You should be able to carry out the computations on a new set of numbers. Try creating your examples. So I'm going to try this right now. And that's the problem that I will face. Question 6. Now the problem is, GCD. This is A of 60 to 24. For n in the natural numbers, okay, so I'm going to try some of those, but for this one, I'm going to have to think. So GCD, 60 and 24. What is GCD equal to? Right. Let's scroll up to see what GCD is equal to. Euclid's algorithm. Euclidean algorithm. From the basic fact remaindering, we have it is clear that a common divisor of f, a, and b is divisor of r, 2, and the result is obvious. Alright, let's have a look. So you're saying that is equal to GCD of 24 and A mod B. So 60 and 24. 60 mod 24. 24, 48, 49, 50, so you got 12. Possibly. And then you go GCD of 12 and 24 mod 12. 0. So Euclid's algorithm, A and B. X is A, Y is B, while Y is greater than 0, so Y is not 0 anymore here. But when Y is greater than 0, you say R is equal to X mod Y, which is the remainder. You set X to be Y and Y to be R, and then you return X when Y is greater than 0. So what does X here even mean, right? Anyway, okay, so GCD 3321. 33 is 1 times 21 plus 12, so then you go 21 and 12 to get 9 as a remainder. 9 and 12, 12 and 9. Yeah, 12 and 9 to get a 3, and then 9 and 3. 9 and 3 is 3 by 3, which is just GCD 30. Determination of GCD 3321. Okay, illustration through manual computation. So sure, I did all that, but what does that mean to me? So from illustration, so from C, 3 equals 12 minus 1 times 9. 3 equals 12 minus 1 times 21 minus 1 times 12. And then you simplify that a little bit to 12 minus 21 plus 12. So 2 times 12 minus 1 times 21, and 3 is equal to 2 times 31 minus 1 times 21, because you go from 12, which is 33 minus 1 times 21, minus 1 times 21. Which then you further simplify to 2 times 33 minus 2 times 21 minus 1 times 21, which is 2 times 33 minus 3 times 21. So note that the GCD, in this case 3, greatest common divisor, is 3, can be written as a function of its inputs 33 and 21. A function of its inputs 33 and 21. This is an extended Euclidean algorithm. Helps in computing inverses. We will study this fact next week. Let A and B be integers, and let n be a positive integer. We say that A is congruent to B, modulo n, and write this. If A and B differ by a multiple of n, if n is a factor of b minus a, every integer is congruent mod n to exactly one of the integers in the set. We're going to find the following operations. The context is clear, we use the above special addition and multiplication symbols interchangeably with their counterpart regular symbols. And determining multiplicative inverses. Okay. GCD computation I think I can understand, so 12 is the greatest common divisor. Right, so greatest common divisor of 12 and 0. We're gonna have hello. And 12 mod 0 . 12 mod 0. What does it mean to mod again? A mod B. So if B is 0, A is 12 equals remainder has to be 12 then. So the remainder is 12. So GCD is that. And then I'm pretty sure there was an axiom, but of 0 and 12. Zero is equal to plus some remainder. So Q is 0, R is 0. So it's just 0. Greatest common divisor. Okay. I'm sure I might come across this idea again. Alright, I'm done. That's fine. Okay. So time to week 1. Okay, so here's my conundrum. I can do a few things. Finish reading Search Algorithms lecture, read chapter 1 of AIA, read model-free, model-based PDF up to the end of section 5. I need to do this before Friday. Today's only Tuesday, so I'll do it on Thursday maybe. These two need to be done as well though. So they're things to be thought about. You know, we could do them a little later, so I'm gonna just do that a little later. And then it's about thinking about the other two subjects as well, which I will say I'll dedicate tomorrow to understanding what's left of computer vision. Let's have a look now, it doesn't matter. Here we go, week 1 is out. Textbooks, practice exams. Alright, so say I open that up, say we open this up, and this up. Introduction, imaging basics, so we have Wednesday and a Friday lecture. Through the week, installing Python, introduction slides, and imaging basics slides, and workshop, intro to image processing. Note the related workshop will occur in the following Lectures and solution will be posted at the end of the week. Reading and links, follow the optional readings if you're interested in learning more about this week's topics. With a view. That's very interesting. So downloads though. We're here.
TV
Okay. I'm okay with that. Let's see, close this. Open this one. Calling masters of IT and most IS students, you have to say and shape future sustainability. You can't study together as students per second. I don't think I can do it. I could, but I could not as well. Okay. Alright. So, we will consider. These are the two lectures that I have to read over. Okay? But, computer vision lecture 1 is one of the things that I've got to do. Or I attend the cryptography lecture 2. Ooh, that's a freaking choice. Either cryptography lecture 2 or computer vision lecture 1. If I do damn. How far are they from each other? Yeah, computer vision, I want to, but I'm gonna have to skip, and I'm doing cryptography instead in my tutorial, and then a computer vision tutorial right after. Actually, no, there is no. Yeah, there's no tutorial right after today. Neither is there for air planning for autonomy. Okay, so that means at most the subjects that I'll have is computer vision lecture 1 or cryptography security lecture 2 and cryptography and security tutorial 1 and statistical machine learning lecture 1. So still there's 4 things, but they're doubled up. That's the problem. So let me write this down. CS lecture 2. CV lecture 1. CS lecture CS tut and SML lecture 1. Yeah. Okay, the problem is that I'll have to read up on CV and SML lectures, which are... Do I have all the lectures with me right now? It's a good question. Set up tasks for week 1. Week 1 software installation and intro to Jupyter Lab. There are no workshops in week 1, however you will need to install software in preparation for week 2. See the recorded video on the workshops or embedded video below. Jupyter Notebook demo, practice manipulating arrays in NumPy, recommended for beginners. Anaconda installation walkthrough, plus intro to Jupyter Lab. I'm still very confused. Why is there no information for this subject? That's sus, very sus. I'm sussed out by the fact that there's no information in this subject. Starts in week 1, tutorial start in week 2. Lecture location, Peter Hall. Lecture consultation. If you can find the corresponding lectures office. Ed discussion board. So I'm putting okay, give me a second. night. Darn, I really wish I could have. Still so much that I wanted to do today, but seems that I've run out of time. So the problem that I need to face right now is what to do here. So save bookmarks, close tabs, practice exam, imaging, basics, all of these. I can just close these. So save to bookmarks, close tabs. These are all me as well. And I was going to write something here, but I won't. And I'm gonna close this as well. So save to bookmarks. Close tabs. And that's all of it. Okay. I'm gonna call it a day, guys. Good night. Good night. It's been fun. And ooh, it's been a lot of people that's come in and out. But alright. Catch you guys probably not tomorrow. Tomorrow's I'm gonna be at uni, but possibly the day after. Oh, Mr. B just woke up. Good night. Yeah, thanks, man. I appreciate it. Calling it a night for me, at least. I'm guessing you live like in America or something. But yeah. Anyway, peace, guys.